Good evening. Welcome for today's session. If my audio and video is clear, I request students to just raise the hand. If audio video is clear, please raise the hand, sir, so that we can start our session for today. Okay, right. Thank you. So in the last class, we have seen how to identify whether the relay to be a directional relay or a non-directional relay. So we are discussing about the protection of interconnected system. In the last class, we have started this. So, so meanwhile, I will just revise so that some of the students are joining late. Correct. Let us revise this topic. Here, in case of interconnected system, the source will be from both the sides. The source for fault current will be from both the sides. So minimum of two relays are to be operated for clearing the fault. Yes or no? For each section, you require minimum of two relays are to be operated. For AB section, R1, R2 are to be operated. For CD section, R3 and R4 are to be operated if there is any fault. So this was the objective type question asked in the previous exam. Minimum of how many relays are to be operated for clearing the fault in case of interconnected system. So minimum of two relays are to be operated for clearing the fault. Okay. So and we have observed the normal current directions and fault current directions, and we have observed that there is a change in direction of current in relays R2 and R3, and we have gone through a procedure which relays are to be directional and which relays are to be non-directional. We don't know which relays are to be selected as directional relays and which relays are to be selected as non-directional relays. Okay, which relays are to be directional and which relays are to be non-directional. For that, what I have done first I have considered all the relays as non-directional relays. First, I have considered all the relays as non-directional relays. I don't know. That's why I have considered all the relays as non-directional relays. So fault F1 is sensitive about R1, R2, R3, R4. But reliable protection is to be obtained by R1 and R2 only. Okay, R1, R2 are to be operated. So what is the condition that must be developed for the fault F1? Time of operation of relay 2 must be less than time of operation of relay 3, relay 4. Then only the relay will, you will get reliable protection. Similarly, I have developed the condition for fault F2. Fault F2 is sensitive by what? R1, R2, R3, R4. But relays R3 and R4 are to be operated. Here you got the condition. Time of operation of R3 less than time of operation of R2 and R1. Okay. So now observe this equation A and equation B. Equation A states that time of operation of R2 should be less than time of operation of R3. B says that time of operation of R3 should be less than time of operation of R2. Okay. You cannot satisfy equation A and equation B simultaneously. If you observe, if you are satisfying A means ultimately you are losing equation B. If you are satisfying B means ultimately you are losing equation A. So if you are using all the relays as non-directional relays, you can't get reliable protection. Understand my point? If you are using all the relays as non-directional relays, you can't get reliable protection. That's why what you have done. So we have gone for getting reliable protection, we need to use the mix of what? We need to use the mix of directional relays and non-directional relays. We need to mix the directional relays as well as non-directional relays. So how to identify? What is the procedure to identify which relay is to be directional and which relay is to be non-directional? Which relay is to be directional and which relay is to be non-directional? We need to identify. So first, what you need to do? Identify the normal current directions. Second, what you need to do? Consider the faults in different sections and observe the direction of currents. Okay. In step 3, what you need to do? If there is a change in direction of current from normal condition to fault condition, then it is a directional relay. Okay. If there is a change in direction of current from normal condition to fault condition, then it is a directional relay. If there is no change, it is a non-directional relay. Okay. Now we have to consider the same. Step 1, identify the normal current direction. Step 2, consider the faults. and observe the direction of currents in the relays. If there is no change from normal condition to fault condition, it is a non-directional relay. If there is a change, it is a directional relay. That is the procedure. Now, once we got this, so we need to check if you are using that directional relays and a non-directional relays mix. So what are the conditions that must be satisfied? So T of R2 should be less than T of R4, T of R3 should be less than T of R1. So the equation 1 and 2 can be satisfied simultaneously and reliable production can be obtained. Here what are the directional non-directional relays? R1 and R4 are non-directional relays, R2 and R3 are directional relays. Okay. So that was the topic that we have discussed in the last class. Now let us start our discussion for today. So now let us take different examples and observe how to identify directional relays and non-directional relays. The problem is given like this. Problem is given like this. This is very important, sir. How to identify directional relays and non-directional relays. Which relays are to be directional and which relays are to be non-directional. So if you consider three sections, somebody is asking what about three sections. So this is source 1 and this is source 2 and here it is connected to source 3. S1, S2 and S3. So this first section is protected by relays R1, R2. Second section is protected by relays R3, R4. Third section is protected by relays R5 and R6. The question is identify directional relays and directional relays and non-directional relays. Non-directional relays. So what is asking here? Identify which relays are to be directional and which relays are to be non-directional. Here what is the question, sir? Identify which relays are to be directional and which relays are to be non-directional. So how to identify? I have given the procedure in the last class. So even if you have missed that, just listen. So this is the system given. Okay. How do you find the solution for that? So first identify what is the system given. This is the source 1 and here you have the source 2 and you have the source 3 here, third source. And this first section is protected by relays R1, R2. Second section is protected by relays R3, R4. This one is protected by R5 and R6. So first, what do you need to do? First, we need to wait. So this is the system given. Okay, this is the system given. First, what you need to do? First step, what you need to do? Identify the normal current directions in the relays. Step one is identify the normal current directions in the relays. How many relays are there? 6 relays. So R1, R2, R3, R4, R5 and R6. Totally there are 6 relays. Identify the normal current directions in the relays. So how do you identify the normal current directions? So generally they are from source to load. R1 observes in this direction, R2 observes in this direction, R3 and R4 observes in this direction, R5 and R6 observes in this direction. R5 and R6 observes in this direction. Okay, this is step 1. Now in step 2, what do you need to do? Step 2, what do you need to do? Consider faults in different sections. Step 2, what do you need to do? Consider faults in different sections. So you consider the fault in different sections now. So first you consider the fault F1 here. First you consider the fault F1. So fault F1, due to fault F1, in step 2 what you are doing? Considering the faults F1. Due to the fault F1, what happens? This source delivers in this direction, this source delivers in this direction, and this source delivers in this direction. Now observe the direction of currents in the relays. Now observe the direction of currents in the relays. Due to this fault, what will be the direction of currents in the relays? So how many relays you have? 6 relays. R1, R2, R3, R4, R5 and R6. So what will be the direction of currents in the relays? Now observe. R1 will observe in the same current direction, but R2 direction gets reversed when compared to normal. R3, R4 will observe the same current directions. Okay. So only there is a change in which relay? R2 relay direction got changed. R2 relay direction got changed. Now consider the fault F2. Now consider the fault F2 in the next section. Now if you consider the fault F2 in the next section, uh, what will be the direction of currents in the relays? Now let us observe that. Now you have considered the fault F2 in the other section. So in the section of R3 and R4, if you consider the fault F2 and observe the direction of currents in the relays. So this is the fault F2. Due to that fault F2, this will be the direction of current observed by the relays, and this will be the direction of current. So now locate about 6 relays: R1, R2, R3, R4, R5 and R6. So observe what is the direction of current in the relay R1. It is same as normal current direction. R2 will be also same, but R3 direction gets reversed. R4 will be same. R5, R6 will be also same. So where there is a change in the operation of what? R3 relay direction got changed. Now what we need to do? We need to consider the fault in the third section. Now we need to consider the fault in the third section and observe the direction of currents in the relays. So if you consider the fault F3 here, this fault F3 is fed by this source as well as this source. Now observe, due to the fault F3, what are the current directions? R1, R2, R3, R4, R5 and R6. In which relay will observe the change in direction? Let us observe. R1 will not change its direction. R2 will not change its direction. R3 will not change its direction. R4 will not change its direction. R5 will change its direction now. R5 will change its direction. R6 will not change its direction. So here R5, there is a change in direction of current. Now this is the step 2. Step 2, what you need to consider? Step 2, what you need to consider? We need to consider the faults in different sections. In step 2, what you need to consider? We need to consider the faults in different sections and observe the direction of currents in the relays. So now, which relays are to be directional and which relays are to be non-directional? If there is no change in direction of current, there is a non-directional relay. So which are non-directional relays? What is the solution? Which are non-directional relays? Observe, is there any change in direction of current in R1? No. So R1 is non-directional relay. And observe R4, is there any change in direction of current? No. R4 is non-directional relay. Observe R6, is there any direction of current change? No. R6 is non-directional relay. R1, R4, R6 are what? Non-directional relays. R1, R4, R6 are non-directional relays. And the directional relays. Which relays are directional? Relays? Now let us observe R2 directional, R3 directional, and R5 directional. So here our analysis is R1 is non-directional, R4 is non-directional, R6 is non-directional, R2 is set to operate in this direction, R3 is set to operate in this direction, and R5 is set to operate in this direction. Okay. So this is the solution. What is the question given? Identify which are the directional relays and which are the non-directional relays. What you need to do? First step, what you need to do? Identify the normal current directions. In step 2, what you need to do? Consider faults in different sections and observe the direction of currents in the relays. So, and if there is no change, it is a non-directional relay. If there is a change in direction of current, then it is a directional relay. Okay. Now, just wait. I will try to visualize this with an animation. Just wait, sir. Just wait a minute. So we have learned how to identify which relay is to be directional and which relay is to be non-directional. Just a minute. Just wait a minute, sir. I'll be showing that. Now, so here there are three sources here that we have considered, and we have identified which relays are to be directional and which relays are to be non-directional. So meanwhile, I will try to show that. Just wait a minute. Now observe here, sir. Now observe this system. I think you are not getting anything. Just wait. So I am sharing that animation screen. Just observe here. So here we have three sections. Here we have three sections, and now observe first what you need to do. First, observe what is the normal current directions observed by the relays. First, observe what are the normal current directions observed by the relays. This is the normal current directions observed by the relays R1, R2, R3, R4, R5, and R6. Next, what we need to do? We need to consider faults in different sections. Faults in different sections. First, fault F1 I have considered. Now observe there is a change in direction of current in R2 relay. There is a change in direction of current in R2 relay. Now next, consider the fault F2 and observe there is a change in direction of current in R3 relay. R3 relay. Okay. Now consider the fault F3. Sorry, here it is printed F2, but it is F3. F3 due to the fault F3. There is a change in direction of current in relay 5. So now, what is your observation? R2, R3, R5 are directional relays. R1, R4, R6 are non-directional relays. Okay. This is how you need to identify which relays are to be directional and which relays are to be non-directional. I think you got the idea how to identify which relays are to be directional and which relays are to be non-directional relays. Okay. So now let us consider one more example to identify which relays are to be directional and which relays are to be non-directional. This is the source 1 and this is the second source S2. And now instead of source S3, here if it is connected with a load, it is connected with a load. Now identify which relays are to be directional R1, R2, R3. R4, R5 and R6. Okay. There will not be any R6 here. So identify which relays are directional and non-directional. Non-directional. Which relays are to be directional and which relays are to be non-directional? Now let us try to identify here. How do you identify? So now let us find the solution for this problem. So how do you identify? So this is a system with two sources given in the question. This is source 1 and this is source 2, and in between here there is one more bus to which the load is connected. This first section is protected by relay 1 and 2, second section is protected by relay 3 and relay 4, and the third section is protected by relay 5. First step, what you need to do, identify the normal current directions. Step 1 is what? Step 1 is what? Identify the normal current directions in the relays R1, R2, R3, R4 and R5. So what will be the normal current directions? R1 observes in this direction, R2 observes in this direction, R3 observes in this direction, R4 observes in this direction, and R5 observes downward current direction. This is the normal current directions in the relays. Next, what you need to do in step 2, what you need to consider faults in different sections. Step 2, what you need to consider the faults. Step 2. In step 2, what you need to do, consider the faults F1 and observe the direction of currents in the relays R1, R2, R3, R4 and R5. Is there any change in direction of current in due to this fault F1? R1 will not change its direction, but R2 will change its direction. R3, R4 will not have any change in its direction, and R5 also will not have any change in its direction. Now consider the fault F2 in this section. For the fault F2, what will be the direction of currents in the relays? R1, R2, R3, R4 and R5. Observe the direction of currents. R1 there will not be any change, R2 there will not be any change, but R3 direction will get reversed, R4 will not change, R5 also will not have any change. And for the fault F3, what are the direction of currents in the relays? R1, R2, R3, R4 and R5. Okay. So R1, this is the fault F3. For the fault F3, is there any change in direction of current in R1? R1 will not change, R2 will not change, R3 will not change, R4 will not change, R5 also will not change. There will not be any change in direction of current even in relay 5. Even in relay 5, there will not be any change in direction of current. Okay. So what is our procedure here? So if there is no change, it is a non-directional relay. If there is a change, it is a directional relay. So solution is what here? What is the answer? What is the answer? Which relays are directional relays and which relays are non-directional relays? Directional relays. So if you observe here, R2, there is a change in direction of current, and R3, there is a change in direction of current. R2, R3. So R2 should be set to operate in this direction, R3 should be set to operate in this direction. And which are non-directional relays? R1, R4, R5. All these are what? Non-directional relays. All these are non-directional relays. R1 is non-directional, R4 is non-directional, R2 is directional, R3 is directional, R5 is non-directional. So the answer is R1, R4, R5 are non-directional relays. R2 and R3 are what? Directional relays. So this is how you need to identify which relay is to be directional and which relay is to be non-directional. Okay. So now so we have observed three different problems. So we have considered. Let us make a conclusion here. So if you observe the first problem that we have considered with two sources S1 and S2. This is the first problem that we have considered, and in this case here the relay 1, relay 2, this section is protected by relay 3 and relay 4. Which are directional and which are non-directional here? R1 is non-directional and R4 is non-directional. R2 is directional and R3 is directional. Okay, this is the first problem that we have solved. Okay, I am concluding here. Okay. Now let us go for the second problem that we have analyzed. In the second problem, we have considered with three sources. We have considered with three sources. Okay. And S1, S2, and S3. Here, this first section is protected by relay 1 and relay 2. Second section is protected by relay 3, relay 4, and this is relay 5 and relay 6. Which are directional and which are non-directional? R1 is non-directional, R4 is non-directional, R6 is non-directional, R2 is directional, R3 is directional, R5 is directional. Okay. Now let us go for the next. This is source 1, this is source 2, and here you have load relay 1, relay 2, relay 3, relay 4, and relay 5. R1 is non-directional, R4 is non-directional, R5 is non-directional, R2 is directional, and R3 is directional. Now, what is your conclusion that you can do here? If you observe the relays which are connected nearer to the source, the relays which are connected nearer to the source are what? The relays which are connected nearer to the source are what? Your observation. The relays which are connected nearer to the source are what? Which type of relays are connected nearer to the source? They are non-directional relays. Here R1, R4 are what? Non-directional relays. R1, R4 are what? Non-directional relays. R6 also non-directional relay. R1, R4 are non-directional relays. Now, which are connected near to the load are what? Directional relays. Near to the load are directional relays. But if you observe this third problem, here R5 is becoming non-directional. R5 is becoming non-directional. R5 is non-directional relay only, no. Because why it is becoming non-directional? For this bus 2, for this bus, for this bus, load bus, this bus acts as a source now. This bus, load bus is drawing the power from this bus. That's why R5 is becoming what? Non-directional relay. That's why R5 is becoming non-directional relay. Generally, we can conclude that the relays which are connected, nearer to the source are what? Non-directional relays, and nearer to the load are what? Directional relays. Okay. So we can make a general statement, but I have given the procedure. Don't confuse here. Okay. The relays, which are connected, nearer to the source, are non-directional relays, and near to the load are, directional relays. Near to the load are directional relays. So this is general note, sir. Okay, general note. Here you can observe near to the source R1, R4 are what? Non-directional relays. Near to the load are directional relays. So R1, R4, R6. Okay, non-directional. R2, R3, R5 directional relays. R1, R4. Even R5 also, because for this bus acts as a source. For this load bus, this bus acts as a source. That's why it becoming what? Non-directional relays. Generally, we can conclude like that. Okay. So conclusion is what? The relays which are connected nearer to the source are non-directional relays, and the relays which are connected near to the load are what? Directional relays. Okay. Now, let us take a parallel system. Parallel lines, and identify which relays are to be directional and which relays are to be non-directional. Which relays are to be directional and which relays are to be non-directional. Even in case of parallel lines, suppose if the first section is protected by relay 1 and relay 2, second line is protected by relay 3 and relay 4. There is only one source. Two lines are in parallel. So which relays are to be directional and which relays are to be non-directional? How do you identify? Now let us consider step 1. What is the step 1? First identify the, so which relays are to be directional and non-directional. That is the question. Okay. So how do you identify which relays are to be directional and which relays are to be non-directional? How do you identify, sir? So solution is like this. First, what you need to do? First, you need to identify the normal current directions in the relays. This is the solution one. So this is the source, and here the load is connected. This first section is protected by relays 1 and 2. Second section is protected by relay 3 and relay 4. First, what you need to identify the normal current directions in the relays. What will be the normal current directions in the relays that you need to identify? R1, R2, R3 and R4. So what will be the normal current directions in the relays? All the relays, always the direction of current is from source to load. Always the direction of current is from source to load. R1, R2, R3, R4. All the relays will observe the same direction of current. Now consider the faults in different sections. Now consider the fault F1. So for the faults F1, what will be the direction of current in the relays? R1, R2, R3 and R4. What will be the direction of current? So one is in this path and the other is in this path and the other is in this path. Okay. So the fault F1, R1 observes in the same current direction. R2 direction gets reversed. R2 direction gets reversed. R3 and R4 will observe the same current directions. Okay. Now consider the fault F2. Now consider the fault F2. For the fault F2, observe the direction of currents in the relays R1, R2, R3 and R4. So the fault F2, one is in this direction and the other is in this direction. So R1 will observe in the same direction, R2 will observe in the same direction, normal current direction, but R4 direction gets reversed, R3 direction is same as normal current direction. Okay. Now what is your observation here? There is a change in direction of current in R2 as well as there is a change in direction of current in R4 relay. Okay. So which relays have to be directional? The same procedure that you have learned is applicable here also. The relays which are having the change in direction have to be what? Directional relays. Otherwise, the relays have to be non-directional relays. So what is your observation here? R1, R2, R3, R4. Which relays are directional and which relays are non-directional? R1, non-directional relay, because there is no change in direction of current from normal condition to fault condition. As there is no change in direction of current, as there is no change in direction of current from normal condition to fault condition, relay R1 is what? Non-directional relay. NDR means non-directional relay. It is not. Okay. So R2 is directional relay. R2 is directional relay. R3 is non-directional relay because there is no change in direction of current. So it is a non-directional relay. R4 is directional relay. Okay. Now observe. So what is our conclusion here? R1 non-directional, R3 non-directional, R2 directional, and R4 is directional. So the relays which are connected nearer to the source, here also it is true. The relays which are connected nearer to the source are what? The relays which are connected near to the source are what? Directional, non-directional relays, and near to the load are what? Directional relays. That is true even in case of this parallel system. Okay. Now, what will be the timing sequence? Generally, the question will be asked on timing sequence also. What is the timing? Which relays has to be operated? Which sequence you need to operate? Now, let us consider the same system that we have got now. So, we have got the source and load. Now observe here, this first section is protected by relays R1 and R2. Second section is protected by relay R3 and R4. Relay R1 is non-directional, relay R3 is non-directional, relay R2 is set to operate in this direction, relay R4 is set to operate in this direction. Okay. Now, fault F1. For the fault F1, the fault F1 is sensed by what? Fault F1 is sensed by which relays? Censored by which relays? Fault F1 is censored by which relays? Observe here. In this direction, R1 will sense, okay, R2 will sense, R3 will sense, but R4 will not sense because one is in this direction and the other is in this direction. R4 will observe only in this direction. R4 will not sense that fault. Okay, R4 will not sense that fault. Which relays are to be operated for reliable protection? Reliable protection means it should disconnect only the faulty section. Other sections should not be disconnected. Reliable protection is achieved by what? R1 and R2. R1 and R2. So R1, R2. Exclusion is with R3. So condition that must be satisfied is what? Condition that must be satisfied is what? So in this path, if you observe in this path, R3 should not operate, R2 should be operated. So what is the condition that must be satisfied? Time of operation of R2 should be less than time of operation of R3. Time of operation of R2 should be less than time of operation of R3. That is a condition that must be satisfied. Okay. Now let us consider the second fault F2 here. So the fault F2, it is censored by what? It is censored by which relays? It is censored by which relays? R1, R3, comma R4. R1, R3, comma R4. Reliable protection is obtained by which relays? R3, comma R4. R3, comma R4. Now, what is the condition that must be satisfied? Condition that must be satisfied. So R1 should not operate. R1 should not operate. So in the R1 path, we have R4. That means T of operation of R4 should be less than T of operation of R1. So you need to satisfy this equation A and equation B. Equation A and equation B. Can we satisfy equation A and B simultaneously or not? Can we satisfy this equation A and B simultaneously? Yes or no? The equation A and B can be satisfied simultaneously or not? Yes, we can satisfy equation A and B simultaneously. So A comma B, equation A comma B can be satisfied 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 simultaneously, can be satisfied simultaneously. So reliable protection can be obtained. Okay, understood my point. So we have discussed about this parallel lines protection. Which relays are to be directional, which relays are to be non-directional. In step one, what do you need to do? This is a step one. What do you need to do? First, identify the normal current directions. In step two, what do you need to do? In step two, we need to consider the faults in different sections. And in step three, what do you need to do? If there is no change in direction of current, it is a non-directional relay. If there is a change in direction of current, it is a directional relay. Okay. And the set direction should be same as what? Fault current direction. And the set direction is to be same as fault current direction. Okay. So, and we have obtained the timing sequence also. Sometimes timing sequence. This timing sequence will be also asked in the questions. What is the timing sequence that must be satisfied? So, fault F1 is censored by R1, R2, R3. But R1, R2 only should operate. For that, time of operation of R2 should be less than time of operation of R3. That must be satisfied. The fault F2 is censored by what? Fault F2 is censored by R1, R3, and R4. But R1 should not, R3, R4 should be operated for the fault F2. So time of operation of R4 should be less than time of operation of R1. So this is how a parallel line is to be protected. Okay. Now let us consider the interconnected system. Let us consider the protection of ring main system. Interconnected system we have completed. Ring main system. Ring main system protection. So how do you protect the ring main system? Ring main means it is forming a loop. Now let us consider here. This is a source S, and here suppose if you have take the 4 buses where the loads are connected here. Now this first section is protected by relay 1 and relay 2. Second section is protected by relay 3, relay 4, and this is protected by relay 5 and relay 6, relay 7, and relay 8. Okay. Now, which relays are to be directional and which relays are to be non-directional? Any idea? That we have came to a conclusion. That relays which are connected nearer to the source. Are what? Non-directional relays. Now the relays which are connected nearer to the source are non-directional relays. So relay R1 non-directional. Relay R8 is also non-directional. Okay. The non-directional relays are what? Non-directional relays are R1 comma R8 because relays which are connected near to the source. Remaining all are what? Directional relays. R2 should operate for the fault in this section. R2 should operate for the fault in this section. R3 should operate for the fault in this section. And R4 should operate for the fault in this section. And R5 should operate for the fault in this section. R6 should operate for the fault in this section. R7 should operate for the fault in this section. So which are directional relays? Which are directional relays? R2, R3, R4, R5, R6, R7. All these are what? Directional relays. R1, R8 are non-directional relays. Remaining all are what? Directional relays. Okay. Because the relays which are connected nearer to the source are what? These two are connected nearer to the source. So that's why they are non-directional relays. All these are connected near to the load. They are what? Directional relays. Okay. So that is the general procedure. Now what is the timing sequence? What is the timing sequence that you need to obtain? What is the timing sequence that you need to obtain here? Now let us observe carefully. For developing the timing sequence, let us consider the faults. Now let us consider the fault F1 in this section. Fault F1 in the first section. So the fault F1 is to be cleared by what? Observe, the fault F1 is to be cleared by what? This fault F1 is to be cleared by what? R1 as well as R2. Fault F1 is to be cleared by R1 as well as R2. Fault F1 is to be cleared by relays R1 and R2. Okay. So what is the sequence that is to be observed? Now let us observe like this here. The source here, and in one direction there is relay 1 which is non-directional relay, and the fault F1 is taking place. Here relay 1 is sensing and it is operating. Is there any sequence of operation required? That means any condition that must be satisfied? No. Okay. Now observe in the other direction. In the other direction. This direction also the fault current flows. Now let us observe in that direction. So this is the source, and here you have now so this is the fault F1. Okay. Now here you have R8, R7, R6, R5, R4, R3, R2. Okay. So R2 is directional, R3 is directional, R4 is directional, R5 is directional, R6 is directional, R7 is directional, R8 is non-directional. Now observe in this path, which are, so this is the fault current path. Okay. So which relays are sensing this fault? So which relays are sensing that fault? Now let us observe here. So here, which relays are sensing that fault? So this fault in this direction, R8 senses, R8 is sensing, R7 will not sense, R8 senses, R7 will not sense, R6 senses, R5 will not sense, R4 senses, R3 will not sense, and R2 will sense. R8, R6, R4, R4, R2, R2. Which relay has to be operated first? Here, any idea which relay has to be operated first? The fault is in this first section. Means which relay has to be operated first? Observe here. For fault in the first section, R1 and R2 has to be operated. So for the fault F1, it is to be cleared by what? R1 comma R2. So R1 no condition is required, but R2 direction these relays are sensing. That means time of operation of R2 should be less than time of operation of R4, should be less than time of operation of R6, should be less than time of operation of R8. So this is the sequence that is to be followed for operation of R2. TR4 less than TR2 less than TR4 less than TR6 less than TR8. So we got the coordination between 2, 4, 6, 8 relays. But remaining relays, how do we coordinate? For that, let us consider the fault F2 in this section. And coordinate. For the fault F2, which relays are to be operated? R8 and R7. For the fault F2, R8 and R7. So fault F2, we need to operate R8 comma R7. So now let us observe here. This is the source. R8 relay, R8 relay, and this is the fault F2. So R8 relay has to sense and R8 relay has to operate. So there is no condition that must be required. Now this is the source S, and in this direction so this is relay 1, relay 2, relay 3, relay 4, relay 5, relay 6, relay 7, and this is a fault. Okay. So R1 is non-directional, R2 is directional, R3 is directional, R4, R5, R6, R7. So here now observe which relays are sensing in this path. R1 senses, R3 senses, R5 senses, R7 senses. So R1, R5, sorry, R1, R3, R1, R3, R5, R7. These are the relays that are sensing in this direction. Okay, but which relay has to be operated? R1 has to be operated. Sorry, R7 has to be operated. R7 has to be operated. So that means because R8 and R6 are to be operated. So what is the sequence that is to be set? Time of operation of R7 should be less than time of operation of R5, should be less than time of operation of R3, should be less than what? Time of operation of R1. So 7531. So equation B and equation A. Equation B and equation A have to be satisfied simultaneously. For equation A, what you have considered? This fault F1 we have considered, and equation B you have considered the fault F2. Okay, fault F1 and F2. Fault F1 in this direction only R1 has to sense and it is operating, but in the other direction R2 has to be operated. For that, you need to set this sequence: TR2 less than TR4 less than TR6 less than TR8. And in the other direction, other fault F2 in this section, so R8 and R7 are to be operated. R8 is operating, R7 is to be operated in this region. So R1, R3, R5 and R7. So time of operation of R7 less than time of operation of R5 less than time of operation of R3 less than time of operation of R1. Okay. Now this is the sequence that must be satisfied. So if you satisfy these two sequences, you will get the reliable production. Even if you satisfy those two sequences, this fault F3 and the fault F4 in this section will be also cleared by R3, R4 and R5, R6. So you'll get the reliable production. So this is about the ring main system protection. This is about what? Ring main system protection. Okay. So we have discussed about radial system, interconnected system and ring main system. So in case of interconnected system, how to identify we have seen, and in case of parallel lines, how to identify we have seen, and even in case of ring main system, how to identify which relays are to be directional and which relays are to be non-directional. We have gone through the analysis. Okay, understood my point here. Okay. So got the idea how to identify which relays are to be directional and which relays are to be non-directional. Now with this that is the application part is completed. How to identify the relays are to be directional and how to identify the relays are to be non-directional. That part is completed. Okay. While doubt session, if you have any doubts, I am ready to clear that. But I am going to the next topic now. That is discrimination for grounded faults. Discrimination for grounded faults. Okay. Discrimination for grounded faults. Grounded faults. What do you mean by that? So how to identify which fault is a grounded fault and which fault is a ungrounded fault? So we have seen about line to ground, line to line, double line to ground, triple line to ground. So here the grounded faults are what? Line to ground, grounded faults, line to ground, and triple line to ground. And how to identify these are what? Grounded faults. Grounded faults. And the remaining are what? Ungrounded faults. These two are what? Ungrounded faults. So now you need to discriminate whether the fault is a grounded fault or ungrounded fault. That means you need to identify whether the fault is a grounded fault or ungrounded fault. So how do you identify whether the fault is a grounded fault or ungrounded fault? How do you identify whether the fault is a grounded fault or ungrounded fault? So I am giving a conclusion that, but you will be studying in fault analysis. You will be studying in fault analysis. For a grounded fault, for a grounded fault, for a grounded fault, neutral current exists. What current exists? Neutral current exists. Okay, for a grounded fault, neutral current exists. For ungrounded fault, neutral current will not exist. Neutral current will not exist. Will not exist. Okay. For a grounded fault, a neutral current exists. For an ungrounded fault, neutral current will not exist. Now I want to discriminate. Now the topic is what? Discrimination for grounded faults. That means we need to identify whether the fault is a grounded fault or ungrounded fault. Here we need to identify whether the fault is a grounded fault or ungrounded fault. So how do you identify whether the fault is a grounded fault or ungrounded fault? Now let us see with the example. Okay. So we have the three-phase system. System is three-phase. This is R phase, this is Y phase, and B phase. So R phase, Y phase, and B phase. Each phase has its own relay. Relays are configured in a phase manner. That means there is a R phase relay for R phase, which continuously, PR means what? Phase relay. PR stands for phase relay. Okay. So there is an R phase relay which continuously monitors R phase, and there is a Y phase relay which continuously monitors Y phase, and there is a B phase relay which continuously monitors B phase. B phase. Okay. So, but by using only this phase relays, we will not have the discrimination for grounded faults. That means we cannot identify whether the fault is a grounded fault or ungrounded fault. We cannot identify whether the fault is a grounded fault or ungrounded fault. Okay. So now here what you need to do, in addition to this phase relays, we need to use what? Earth relays. In addition to the phase relays, we need to use what? Earth relays. Earth relays are also to be used. Earth relay is to be used along with phase relay. Earth relay will measure what? Neutral current. It will measure what? Neutral current. Neutral current is what? Sum of the three phase currents, IR plus IY plus IB. IR plus IY plus IB. This ER stands for what? Earth relay. Earth relay. So this earth relay will measure what? Neutral current. So if the trip signal is given by the earth relay, means it is a grounded fault, because for a grounded fault, which current exists? Neutral current exists. For a grounded fault, which current exists? Neutral current exists. So if the trip action is given by the earth relay, that means the fault is what type of fault? The fault is a grounded fault. So in what is our conclusion here? In order to have the discrimination for grounded faults, that means if you want to identify whether the fault is a grounded fault or not, we need to have an earth relay along with what? Phase relays. Okay. Now what you can write here, in order to have discrimination for grounded faults, we need to have earth relay along with phase relays, So we need to have earth relay along with phase relays. So during normal condition, there will be phase current. What will be the neutral current during normal condition? During normal condition, that is when there is no fault, will there be any neutral current, sir? Neutral current is zero during normal condition. but phase current exists during normal condition. But the phase current will exist during normal condition. So what is the set value of phase relay and what will be the set value of earth relay? Set value of phase relay, set value of phase relay will be around, the set value of phase relay will be around 110 to 120% of full load current. 120, 120, 110 to 120% of full load current. That is the set value of phase relay. What will be the set value of earth relay? Generally 100% of the full load. Okay, that is suppose if the full load current is 100 amperes, phase relay will have a set value of 110 or 120 amperes. Okay, um, but what about earth relay? During normal condition, will there be any neutral current? Neutral current is zero during normal condition. The set value of earth relay will be only 10 to 20% of full load current. Okay, the set value of earth relay, the set value of earth relay, earth relay will be around, will be around, the set value of earth relay will be around 10 to 20% of, 10 to 20% of full load current, full load current. Okay, because during normal condition, what will be the neutral current? Normal condition, normal condition, during normal condition, neutral current is what? During normal condition, neutral current is zero. So that's why it is around 10 to 20% of full load current. Neutral current exists only when the fault takes place. So neutral current will exist only when the fault current takes place. Okay. Now, what is your observation here? When a grounded fault takes place, when a grounded fault takes place, what is my conclusion that I given? Neutral current exists when a grounded fault takes place, because the fault current will be through the ground. The fault current will be through the ground. Why I am saying this? Why I am saying this? Because suppose if you consider the three-phase system like this, if you consider the three-phase windings R, Y, and B. Suppose if the neutral has been grounded, neutral has been grounded. Now, when a grounded fault takes place, when suppose when a line to ground fault takes place like this, so what is the path for fault current? So the path for fault current is like this. The fault current will complete its path in this direction. Okay. This is the path for fault current. This is the path for fault current. Okay. So with the neutral current exists only in case of what? Grounded faults. But when ungrounded fault takes place, suppose if there is an ungrounded fault line to line, there is no neutral current. There will be no neutral current. The fault current will complete its path in this direction only. Okay, neutral current will not exist for ungrounded faults. Okay, now my question is, the sensitivity of earth relay will be more or phase relay will be more for grounded faults? The sensitivity of earth relay will be more or phase relay will be more for grounded faults? Earth relay will be more because it has set value around what? 10 to 20% of full load current. So whenever a grounded fault takes place, so whenever a grounded fault takes place, which relay will operate first? Whenever a grounded fault takes place, which relay will operate first? Earth relay will operate first. Whenever a grounded fault takes place, earth relay will operate first. Okay. So what is our observation here? The sensitivity of earth relay, earth relay will be more, for grounded faults, for grounded faults when compared to, when compared to when compared to phase relays, when compared to phase relays. So when grounded fault takes place, which relay will operate first? Earth relay will operate first. So when grounded fault takes place, when grounded fault takes place, earth relay will operate first. Earth relay will operate first. Will operate first. Earth relay will operate first. So if the trip action is given by the earth relay, means it is a grounded fault. So what is our conclusion here? If trip signal is given by earth relay, means it is a grounded fault. It is a grounded fault. It is a grounded fault. If the trip action is given by the earth relay means it is a grounded fault. So our topic is what? Here what is the topic? Discrimination for grounded faults. Here the topic is discrimination for grounded faults. That means we need to identify which are grounded faults and which are ungrounded faults based on a relay trip action. So grounded fault means neutral current exists. Ungrounded fault means neutral current will not exist. So we have the three-phase system, R phase, Y phase, and B phase. Each phase has its own phase relay, R phase, Y phase, and B phase. In order to discriminate whether the fault is a grounded fault or not, along with phase relays, we require what? Earth relay. Along with phase relays, we require the earth relay. Okay. So earth relay will sense what? Neutral current. Earth relay will sense what? Neutral current. Okay. So in order to discriminate, we have earth relay along with phase relay. What is the set value of phase relay? Phase relay will observe the normal current also. During normal load current also it will observe. That's why the set value of phase relay will be around 110 to 120%. Phase relay set value is 110 to 120% of full load current. Earth relay set value is what? 10 to 20% of full load current. 10 to 20% of full load current. So when grounded fault takes place, which relay will operate first? Earth relay will operate first, because the sensitivity of earth relay will be more when compared to phase relay for grounded faults. So if the trip signal is by earth relay means it is a grounded fault. Okay, that is how we can discriminate whether the fault is a grounded fault or ungrounded fault. Now the question is, how many minimum number of phase relays and earth relays are required for complete protection of the system? Now the question is, this question was asked in previous exam. How many minimum number of number of phase relays phase relays how many minimum number of phase relays and earth relays are required for complete protection of the system, protection against complete protection of system. That means you need to, how many phase relays are required you need to identify, and how many earth relays are required that you need to identify. So you need to give the protection against any type of fault. We need to give the protection against any type of fault. How many minimum number of phase relays and earth relays that are required? So how do you find the solution? Suppose if you take a line to ground fault. Line to ground fault means out of three phases, if any one of the phase short circuited to ground, it is known as line to ground fault. So it is a grounded fault or ungrounded fault? It is a grounded fault or ungrounded fault? It is a grounded fault. It is a grounded fault means neutral current exists or not? Neutral current is not equal to zero. So here neutral current is not equal to zero means one earth relay is sufficient. So for sensing line to ground fault, you require one earth relay. Okay. Now let us go for the remaining faults also. Now let us take line to line fault. How many possibilities are there for line to line fault? There are three possibilities. R, Y, P, three phases. So line to line fault means any of the two phases short circuited. There may be fault between RY, there may be fault between YB, and there may be fault between R and B. Okay. Now if you can here, neutral current is equal to zero. So earth relay is not required. So we require what? Phase relays. Suppose I put one phase relay on R phase. I put one phase relay on R phase. So it will sense this fault. And if you put the phase relay on R phase, will it sense this YB fault? No, because it is not sensing the fault current. So you require the second phase relay. So you require minimum of how many phase relays? Two phase relays. So minimum of two phase relays are required for protecting which type of fault? Line to line fault. For protecting line to line fault, we require what? Minimum of two phase relays. For protecting the system against line to line fault. Now let us go for double line to ground fault. Double line to ground fault means what? Out of three phases, if any of the two phases are short circuited to ground. Here neutral current is not equal to zero because the fault is a grounded fault. So one earth relay is sufficient. Earth relay will sense the double line to ground fault. Okay. Next coming to the triple line fault. Triple line fault. It is a balanced fault or not? Triple line fault. Triple line fault. So RYB. So if all the three phases are short circuited, so it is a balanced fault. It is a balanced fault. Balanced fault means what? Balanced fault means the fault current is same in all the three phases. The effect of fault is same on all the three phases here. So one phase relay is sufficient. One phase relay is sufficient for giving the trip action in case of triple line fault. Okay. Now triple line to ground fault. 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 Triple line to ground fault means out of three phases, if all the three phases are short circuited to ground, then it is, this is also a balanced fault. This is also a balanced fault. So there is a neutral current is zero. Even in this case, the neutral current is zero. So you require what? One phase relay only. One phase relay. Triple line or triple line to ground, both are same. The fault current will be same. So now observe, for line to ground fault, you require one earth relay. One earth relay is sufficient because it is a grounded fault. Neutral current will exist. So one earth relay is sufficient. So line to line, it is not a grounded fault. Not a grounded fault. So here phase relays are required. For line to line fault, two phase relays are required. Double line to ground fault, one earth relay is sufficient because neutral current will exist. And triple line or triple line to ground, both are same. So one phase relay is sufficient. One phase relay is sufficient. So minimum number of phase relays are how many? Two phase relays and one earth relay is sufficient. Minimum number of two phase relays and one earth relay are required for complete protection of the system against any type of fault. Against any type of fault, we require minimum of two phase relays and one earth relay. So what is the conclusion here? What is your conclusion here? What you can write? So minimum of two phase relays and one earth relay is required for complete protection from any fault, any type of fault, any type of fault. So minimum of two phase relays and one earth relay is sufficient for protecting the system against any type of fault. I think you got the idea here. Okay. Now just wait, sir. So minimum of two phases and one earth relay is required for complete protection of the system against any type of fault. Now let us take let us try to solve the questions given in your workbook. Okay. Now let us try to solve that. Wait, I am opening that file. Just wait a minute. So now protective relays. Okay. Now observe this first question. Now let us observe this first question here. Now new share. I am sharing this. I think you are getting the question screen now. So observe this first question given in your material. First question, if you observe, if the fault current is 2 kiloamperes, now let us try to solve the CROs given in your classroom objectives, given in your material. First question, try to solve this. If the fault current is 2 kiloamperes, what is given? If the fault current is 2 kiloamperes, relay setting is 50%. Fault current is 2 kiloamperes, relay setting is 50%. CT ratio is 400 by 5. Calculating the plug setting multiplier of the relay. Try to solve this. Calculate the plug setting multiplier of the relay here. Okay. Try to solve this, sir. Try to solve this first problem given in your protective relays. Okay. Try to solve PSM. What is asking to solve? PSM. I think I am moving to the workbook and try to solve this. Fault current is 2 kiloamperes, relay setting 50%, CD ratio 400 by 5. Okay. So classroom objectives. Classroom objectives, CRO means classroom objectives. First question. What he has given? CD ratio is 400 by 5. Relay setting given as how much here? 50%. Relay setting given as 50%. And fault current is 2 kiloamperes. Fault current is 2 kiloamperes. IF is 2 kiloamperes. Calculate PSM. How do you calculate PSM? So what is the relation? How do you find the solution for this? How do you find the solution for this here? So PSM is equal to what? Fault current by CT ratio multiplied with what? Relay pickup value. Relay pickup value. So here fault current given, CT ratio given, but relay pickup value is not given. How to solve that? Relay pickup value is equal to relay setting multiplied with the rated current of the relay. Rated current of the relay. So relay setting is how much? 50%. 50 by 100 into rated current of the relay. Here rated current of the relay not given. By default rating of CT, secondary is the rated current of the relay. So how much do you get? 5 on the 5 to the. That is how much? 2.5 amperes. Relay pickup value is 2.5 amperes. Now PSM is fault current is how much? 2 kiloamperes. 2 into 10 power 3. CT ratio is how much? 400 by 5 into relay pickup value, that is how much? 2.5 amperes. Okay, 2.5 amperes. Now if you simplify this, you will get the PSM. Try to solve and post the answer, sir. Try to solve and post the answer. What is the PSM calculated? How much? 10. PSM is how much, sir? 10. Understood this question? First question. PSM is 10. Understood how to calculate the PSM or not? So he has given CT ratio, relay setting given, fault current given. He is asking to calculate what? PSM. He is asking to calculate PSM. This is the first question that is given in your CRO. Okay. Got my point? Got my point or not? Okay. I'm moving to that question screen again. Now, let us try to observe this sixth question first. Observe the sixth question there. We will come to the remaining questions again. Observe this problem number 6. 5 ampere 2.2 second overcurrent relay is connected to the supply circuit through 400 by 5 CT. Relay is set to 50%. TMS is 0.5. Fault current is 1000 amperes. Relay characteristic is given below. Calculate the operating time of the relay. Observe this problem number 6. Observe this problem number 6 and try to solve this problem number 6. A 5 ampere 2.2 second overcurrent relay is connected to a supply circuit through 400 by 5 ampere CT. The relay is set at 50% and TMS is 0.5. If the fault current is 1000 amperes, the relay characteristic is given below. What is asking? The operating time of the relay. He is asking to calculate what? Operating time of the relay. So how do you calculate the operating time of the relay? Now let us try to solve this. CT ratio given 400 by 5, relay set 50% and fault current 1000 amperes. I am moving to the question workbook screen. Now let us solve problem number 6. Problem number 6 in your CRO, classroom objectives. Okay. So here fault current given as how much? 1000 amperes. And relay setting given as 50%. Relay setting given as 50%. And CT ratio 400 by 5. CT ratio is how much? CT ratio is 400 by 5. First calculate PSM here. First what you need to calculate PSM. PSM is equal to fault current by CD ratio multiplied with the relay pickup value. Relay pickup value. Here fault current is how much? 1000 by CD ratio is 400 by 5. Relay pickup value. How do you calculate relay pickup value? Relay setting. Relay setting is 50 by 100 into rated current of the relay is 5 amperes. Now, to simplify this PSM, how do you get? Calculate PSM, sir. I request you to calculate the PSM and post the answer. Calculate PSM, sir. Calculate PSM and post the answer. So what is the PSM that you got? PSM is 5. PSM is 5. So you got the PSM, but he is not asking PSM. What is asking? He is asking to calculate the operating time of the relay. Operating time of the relay. I am going back to the question. I am going back to the question here. Observe. So in this, what he has given time multiplier setting is 0.5, and for PSM of 5, what is the time in seconds given? 1.4. But we have calculated PSM as what? 5. For PSM of 5, what is the time in seconds given? For PSM of 5, what is the time in seconds given? For PSM of 5, the time in seconds given is 1.4 seconds. That means this is for total rotation. But TMS is given as what? 0.5. Okay. Now, I am going back to the screen. Here, what he has given, is, just wait. He has given time multiplier setting. TMS is 0.5. TMS is 0.5. For PSM of 5, the time in seconds given is 1.4. This is from the table data. That is specified by the manufacturer. Now we need to calculate the actual operating time of the relay. So TMS, what is the relation? What is TMS? Actual time of operation of the relay. Actual time of operation. Actual time of operation of relay in seconds. Actual time of operation of relay in seconds by time of operation. Time of operation specified by manufacturer. Specified by manufacturer in seconds at that PSM, at particular PSM or PSM of 1. Okay. So here TMS given as how much? 0.5. We need to calculate actual time of operation. Actual time of operation. Actual time of operation in seconds. By time of operation specified by the manufacturer is how much? 1.4. 1.4. Now from this, what is the actual time of operation? What is the actual time of operation? What is the actual time of operation in seconds? What will be actual time, sir? 0.5 into 1.4. 0.5 into 1.4. So how much you get? 0.7 seconds. 0.7 seconds. Understood my point here? So how to solve this problem, sir? First you need to calculate. He has given fault current, relay setting and CT ratio. And PSM we need to calculate from that. For that particular PSM, what is the time of operation given? 1.4 seconds given. So TMS is how much? 0.5. So for that TSM relation that I have given in the last class, TMS is equal to actual time of operation by time of operation specified by the manufacturer in seconds at that PSM. Okay. 0.5 is equal to actual time of operation in seconds by the time of operation specified by the manufacturer. So the data is given in the table. Now I am resharing that question screen. And just wait. So observe here. So how much? 0.7 seconds. 0.7 seconds. Okay. Answer is B. Understand my point? This is problem number 6. Okay. I think all of you got this idea. Now try to solve problem number 7. Try to solve problem number 7. This problem number 7. Try to solve this problem number 7, sir. Problem number 7. What he has given? Try to solve problem number 7. What he has given? 90 degrees connection relay, direction relay is protecting parallel feeders. Voltage coil of the impedance relay is having an impedance of 0.1 plus j 0.1 ohms. The fault current lags the voltage by 90 degrees. The fault current lags the voltage by how much? 90 degrees. The maximum torque developed by the relay is 10 Newton meter. What is the operating torque? Understand my point here? Okay. So 90 degrees, can I observe this question? So one question, read carefully. 90 degrees directional relay is protecting the parallel feeders. Voltage coil of the impedance relay is having 0.1 plus J 0.1 ohms. The fault current lags the system voltage by 90 degrees. The maximum torque developed is 10 Newton meter. What is the operating torque? Okay. Understood my point? Now let us try to solve this. Problem number 7, CRO. Okay. Classroom objectives, problem number 7. Problem number 7, CRO. Now listen this carefully. What he has given 90 degrees connection. 90 degrees connection. 90 degrees connection. Suppose if for an R phase relay, if you are analyzing, this is VR, this is what? VRY. So this is 90 degrees. This is how much? 90 degrees. Now, what is saying? The fault current lags the system voltage by 90 degrees. So the fault current or CT current will be in phase with VRY because the VR is the actual voltage. It lags the system voltage by 90 degrees means IF will be in phase with VRY. Okay. Now the flux phi SC will be in phase with this VRY. Okay. Now, and he has given the current IV. He has given the PT coil current is IV and the flux is phi V. This angle theta V. So he has given ZV impedance angle is 0.1 plus J 0.1. This is the PT coil impedance given as 0.1 plus J 0.1. So what is theta V? Tan inverse of zero point 0.1 by zero point 0.1. How much do you get? 45 degrees. 45 degrees. Theta V is how much? 45 degrees. Now, force or torque directly proportional. Torque or force, that is force is directly proportional to torque. So, what is the expression for operating force? Some constant K1 into phi V into phi SC into sine of angle between phi V comma phi SC. Sine of angle between phi V comma phi SC. So this is maximum force. Yes or no? This is the maximum force. So we can rewrite it as F naught is equal to F max into sine of angle between phi V comma phi SC. Yes or no? Now we can rewrite this expression in terms of torque. T operating torque is equal to maximum torque into sine of angle between phi V comma phi SC. So what is maximum torque? T max given as maximum torque given as 10 Newton meter. In the question, maximum torque given as how much? Maximum torque given as 10 Newton meter. In the question, maximum torque is given as 10 Newton meter. So 10 Newton meter sine of, what is the angle between two fluxes? 45 degrees. Sine 45 is what? Sine 0, 0, sine 30, 1 by 2, sine 45 is 1 by root 2. So 10 by root 2. 10 by root 2. So how much do you get? How much do you get? 7.07 Newton meter. So operating torque is how much? 7.07 Newton meter. I think all of you got this idea. He has given 90 degrees connection. Means actually it should sense VR, but it will sense what? Sorry, not VY. Sorry, here I have written wrong. It is what? In 90 degrees connection, what voltage it will be sensing? VYB it will be sensing. VYB. Okay. Now in 90 degrees connection, he has given. What is saying? The fault current lags the voltage by how much? 90 degrees. So VR and IF will lag by how much? 90 degrees. IF is nothing but this CT flux only. This is nothing but CT coil excitation. This is nothing but PT current. Okay. So CT excitation is with phi SC. PT excitation is with IV. Here the impedance angle of that PT coil is given 0.1 plus J 0.1. So theta V can be calculated from that. So force is directly proportional to what? Phi V phi SC sine of angle between the phi V and phi SC. So from that we can calculate this. So this is how you need to solve. I think you got the idea how to solve this problem. So now I am moving back to the question area. So now observe this problem number 7. Answer is what? 7.07 Newton meter. 7.07 Newton meter. Okay. Problem number 7 completed. So now let us try to solve this problem number 2. Now try to identify this problem number 2. Now I request the students to concentrate on problem number 2. Problem number 2. Plug setting of a negative sequence relay. What he has given? Plug setting of a negative sequence relay is 0.2 amperes. Flux setting of the negative sequence relay is given as how much? 0.2 amperes. CT ratio is 5 is to 1. CT ratio is given as 5 is to 1. What is the minimum line to line fault current for the operation of the relay? What is asking? What is the minimum line to line fault current for operation of the relay? How do you solve this? Let us analyze. Try to solve this. Flux setting of the negative sequence relay. Flux setting of the negative sequence relay is 0.2 amperes. CT ratio is 5 is to 1. Minimum line to line fault current for operation of the relay. Okay. Read out that second question. We will try to solve that. Okay. Flux setting of the negative sequence relay is 0.2 amperes. CT ratio is 5 is to 1. CT ratio is 5 is to 1. Minimum value of line to line fault current for relay operation. Okay. Now let us go back to our answer book. Problem number 2. Problem number 2. Let us try to solve this. So he has given negative sequence relay. Which type of relay he has given? Negative sequence relay. Negative sequence relay. So negative sequence relay will sense what? Negative sequence current. Negative sequence relay will sense negative sequence current. Okay. So here minimum negative sequence current. What he has given? Plug setting. Plug setting of negative sequence relay. Plug setting of negative sequence relay is 0.2 amperes. That is given 0.2 amperes. Here amperes given. It is not PSM. It is not PSM. That is nothing but minimum negative sequence current on the relay side is how much? 0.2 amperes. Okay. Here IR2 minimum. That is nothing but minimum negative sequence current on secondary side on secondary side minimum negative sequence current on secondary side is how much? 0.2 amperes. 0.2 amperes. Now we have calculated this IR2 minimum that is given in the question, but on primary side what is the IR2 minimum? On primary side what is the IR2 minimum? How do you calculate? Capital IR2 minimum. Okay. Minimum negative sequence current on primary side how do you calculate? So this CT ratio is given as 5 is to 1. CT ratio is 5 is to 1. 0.2 into 5 by 1. So how much do you get? 1 ampere. 1 ampere is the minimum negative sequence current on primary side. But he is not asking minimum negative sequence current. What is asking? Minimum line to line fault current. Now let us observe. For a line to line fault, in fault calculations you will be studying, sir. In fault studies you will be studying. Okay, when line to line fault, IF is root 3 times of IR2. Root 3 times of IR2. Okay, this you will be studying in faults. In faults you will be studying. Just use this relation here. Use the relation. So IF minimum fault current is root 3 times of IR2 minimum. Root 3 times of IR2 minimum. Okay. Root 3 times of IR2 minimum is how much here that you have calculated? IR2 minimum is how much? 1 ampere. So root 3 into 1. So that is root 3. 1.732 amperes. This is the minimum fault current. This is the minimum fault current. Okay. That is required for relay operation. This is the minimum fault current required for relay operation. Okay. Understood my point? So here what he has given, the plug setting of the negative sequence relay. Relay which is used is what? Negative sequence relay. That means it will sense the negative sequence current. It will sense what? Negative sequence current. Minimum negative sequence current required for relay operation given as how much? 0.2 amperes. That is given in the question. So if you transfer this minimum negative sequence current on secondary side to primary side, multiply with what? This 5 by 1 is what? CT ratio. 5 by 1 is CT ratio. So use the CT ratio to transfer that. So we got minimum negative sequence current on primary side. But here line to line fault minimum current. Line to line fault minimum current. For line to line fault, relation is IF is root 3 times of IR2. Root 3 times of IR2. Okay. IF minimum will be how much? Root 3 times of IR2 minimum. So minimum fault current is how much? 1.732 amperes. 1.732 amperes. Okay. Now I am sharing that screen once again. So here we observe minimum line to line fault current is 1.73 amperes. Here he has given 0.2 amperes given. Don't take it as PSM because PSM will not have any units. 0.2 amperes means the relay set value is 0.2 amperes. Okay. Negative sequence relay will sense only the negative sequence current. So answer is 1.732 amperes. I think you got this. You got the idea. Okay. How to solve this. Understood my point? So we have solved some problems on this CR. Now let us go for the next topic. I'm sharing the screen once again. Just wait. Okay, right. Now let us go for the next topic. That is nothing but distance relays. That is nothing but distance relays. Where do you use distance relays? What is the application of distance relays? And when the distance relay will be operated? Now let us see. Now let us see what is the use of distance relays. Where do you use the distance relay and when the distance relay will be operated? Okay. Here, distance relays are used in protection of transmission system. Distance relays are used in protection of transmission lines or transmission system. Okay. And when will the distance relay operate? Here, distance means what? Okay. Here, distance means what? Here, distance is in terms of sorry for disturbance, sorry for delay. Due to some technical problem, it has been logged off. I think all of the students are there. Okay. If my audio, video, and screen is clear, just raise the hand. If audio, video, and screen is clear, just raise the hand, sir. If audio, video, and screen is clear, just raise the hand so that we can start our session. Okay, right. Thank you. Thank you. Right. Thank you, sir. Okay. Now let us observe here. Distance relays. Now we are discussing about what? Distance relays. Distance relays are used in protection of what? Distance relays are used in protection of transmission lines. Distance relays are used in protection of what? Transmission lines. When the distance relay will be operated? When the distance relay will be operated? Here, distance is in terms of impedance, reactance, and admittance. Okay, distance relay will be operated when the distance seen by the relay is less than the set distance. Here, important point is distance relay will be operated. Distance relay will be operated. Will be operated. Will be operated when the distance seen by the relay. When the distance seen by the relay. Seen by the relay is less than set distance. So whenever the distance relay observes the distance less than the set distance, the distance relay is expected to operate. Here distance is in terms of what? Impedance, reactance, and admittance. Here distance is in terms of impedance, reactance, and admittance. Impedance, reactance, and admittance. Here, distance is also known as reach of the relay. Here, distance is also known as what? Reach of the relay. Okay. Here, distance is also known as distance is also known as also known as reach of the relay. Reach of the relay. Distance is also termed as what? Reach of the relay. Okay. Now, this distance relay is a non-unit type protection scheme. Distance relay is what? Non-unit type protection. Distance relay is a non-unit type protection scheme. Protection scheme. Non-unit type protection scheme. Okay. Now, distance relays are used in protection of transmission lines. Distance relay is operated when the distance seen by the relay is less than the set distance. Here, distance is in terms of what? Impedance, reactance, or admittance. Okay, and distance is also known as what? Reach of the relay. Distance relay is a non-unit type protection scheme. It is a non-unit type protection scheme. So here we will be studying about impedance relay, reactance relay, and admittance relay. We will be studying about impedance relay, reactance relay, and admittance relay. Okay. Now let us take the doubt session. After the doubt session, we will start that. What do you say? We will start that impedance relay, reactance relay, and admittance relay. Okay. Now I will take the doubt session. I am lowering all your hands. Just wait. If you have any doubt, you can raise your hand. I am just lowering all your hands. If you have doubt, you can raise your hand. I will clear your doubts. Okay. Aishwarya Venkatesh,
Hello, sir.
your doubt.
Sir, what do you mean by reliable protection, sir? I didn't understand.
Reliable protection means, now let us go for the slide here. Okay. Suppose if you observe here, fault F1 is there. Okay, you are getting this screen.
Yes, sir.
Fault F1 is to be cleared by relays R1 and R2.
Yes,
Okay,
sir. Yes, sir.
but the fault F1 is fed by the three sources. That means in this direction, like this. Understood my point?
Yes, sir.
That means it is observed by R4, R6 also. Yes or no?
Yes, sir.
That means if R4 is operating, unnecessarily the loads which are connected to these buses will be losing the power or not.
Yes, sir.
Is that reliable?
No, sir.
No. That means whatever the faulty section is to be disconnected, only that particular section has to be disconnected. The other section has not to be disconnected. That is the problem.
Okay.
Reliable means only the faulty section has to be disconnected. Remaining healthy section has to be connected to the source. Okay.
Okay, sir. Sir, in
Got my point?
4F, sir.
Uh, what is your doubt?
Sir, you say that R5 is non-directional relay, no, sir?
Yes.
How, how is it non-directional, sir?
There is no change from normal condition to fault condition. No?
Yes, sir. Whenever fault 1 occurs, it will be what is it will be less resistance path, no, sir. Short circuit occurs, then the current
Which
must
one?
flow towards
Which
the
one?
F1, no, sir. R5 for the relay
No, no,
all
no.
cases.
Here, if you observe this fault F1, this is load, sir. This is not source.
Okay, sir.
This is load, no? This is
Yes, sir.
load. This is not a source. Okay. Is your doubt clear?
Sir, here short circuit occurs, the current will find the low resistance path, no, sir. So it should not
Yes.
go through load. It should go through this, pass through this fault 1, no, sir.
Yes. If there is no current, current will be zero. What happens? There is. It is not exceeding that limit. No. Suppose if the fault, suppose if you observe in this direction, this part, this impedance, this line impedance will be there. Yes or no?
Yes, sir.
So suppose this is with some impedance and fault F1. Okay, and this is the remaining load condition. This is the load impedance. Okay, So majority of the current passes through this path because this is a dead short circuit here.
Yes, sir.
There will not be any current through this path in such case. What happens if there is no current? It will not sense. No,
Okay, sir. Sir,
there is no issue with that. But here the fault F1 is to be censored by relays R1 and R2. That's it.
okay, sir. Sir, in 9F, sir.
In the 9F. What is your doubt?
9F. Here, you said time for the relay should be R2 should be less than R3, no, sir?
Yes.
Once explain that point, sir.
So if you observe in this direction, which relays are sensing that fault? Fault
R2,
F1. R2 and
R3, R1,
R2 and R3 senses. R4 will not sense because the R4 direction is set to operate in this way. No?
Yes, sir.
So R4 will not sense. Only R3 and R2 will sense. But for fault F1, which relay has to be operated?
Fault F1, R2, sir.
R2. So that means time of operation of R2 should be less than time of operation of R3.
Sir, in 20F, sir, last one.
20F. Now what is your doubt?
Sir, here two phase, you said for LL, line to line fault, in line to line fault, sir. You said only two phase relays are enough, no, sir?
Yes, sir, two phase relays are sufficient. Because when there is fault between R and Y, this phase relay will operate. Between Y and B, you require this additional phase relay. Okay, this phase relay will operate. Between R and B, these two relays will be operated. Here we need to sense the fault. We don't know. That's why we are keeping. We don't know where the fault takes place. Okay, these are the three maximum possibilities. Understood my point? These are the three maximum possibilities. We don't know where the fault takes place. That's why we are keeping two phase relays.
And for triple line to line fault, one phase relay is enough, sir.
Yeah, that's sufficient because this is a balanced fault. Balanced fault means all the three phases will carry the same fault current.
Here we connect phase relay across three lines, sir. How?
Across three, see, relays are configured in phases. Only any one of the phase, if you connect one relay, it will sense that triple line fault. See, in triple line fault, IR, IY, IB will be existing. No, all the three are equal in magnitude. So no need to use. We don't need three phase relays here. Only one phase relay is sufficient.
Here we connect across only one phase, sir.
Only in series with only one phase. Only one phase, if you sense, that is sufficient.
That how can we know? Also, YMP also.
Listen here. My meaning is here minimum of how many phase relays and earth relays are required for complete protection. That means you need to detect all the faults. We need to detect all the faults. So here for first let us observe from line to ground fault onwards. For line to ground fault, it is a grounded fault, so neutral current will exist. Yes or no?
Got it, sir.
So one earth relay is sufficient. Listen here first. One earth relay is sufficient. Okay. If there is an earth relay, that will sense the line to ground fault and it will give the trip action. That is okay. For line to line fault, you don't know, there are three possibilities. So for three possibilities, you require at least two phase relays. Because one phase relay, if you connect here, it will sense RY. This phase relay will not sense Y and T fault. That's why you have kept second phase relay here. So for line to line fault, you require at least two phase relays. For double line to ground fault, it is a grounded fault and earth relay is sufficient. For triple line fault, it is a balanced fault. Balanced fault means all the three phases will carry the same magnitude of current. So no need to sense all the three phase currents. Any one phase current if you sense, that is sufficient. So one phase relay is sufficient for triple line. On the same lines, triple line to ground fault is also a balanced fault. Balanced means all the three phases will carry the same magnitude of current. So one phase relay is sufficient. So minimum of two phase relays and one earth relay is connected in the system.
Yes.
Is your doubt cleared?
To connect only one phase relay, we before that we have to know it is line to line fault, no, sir. Without knowing how can
it is not in your hands. Fault is not in our hands, sir. We need to detect all the faults. For detecting all the faults, we require at least 2 phase relays and 1 earth relay.
Okay, sir. I got it, sir.
Okay. Vinita. Ask your doubt.
Sir, in inline system, sir.
What is the doubt in the inline system?
Sir, in inline systems, you told that the R1 and R8 are non-directional, sir.
Here also R1, R8 are non-directional. Okay.
Yes, sir. In the previous conclusion, you told that the relays which are connected near to source are non-directional, near to load are directional, no, sir.
The same I have used here.
Sir, just open conclusion slide, sir.
This one, huh?
Sir, conclusion. Those 3 problems. Conclusions. Yes, sir, this one, sir. Sir, in the third one, the relay which is nearer to the load is
See
non-directional.
here, for his observe here. This is the load bus. No, this
Yes, sir.
one is load bus. Okay. For this load, this bus acts as a source. For this bus, suppose this is bus X, this is bus Y. For bus X, bus Y acts as a source or not?
Yes, sir.
That's
So
why
we
it
should
becomes a
consider it
direct
is
non-directional.
nearer to source, sir.
Generally, here, if you consider this bus X is fed from bus Y only. No, there is no other source. So this
Yes, sir.
bus acts as a source for this bus. Okay.
Okay, sir.
Mute, sir. Mayan,
Hello, sir.
ask your doubt.
Sir, that 90-degree problem, sir.
What is your doubt in 90-degree problem?
Sir, please explain once again, sir.
This one only, no?
Sir. This.
So he has given in 90 degrees. How do you connect? Actually, VR you need to sense, but we are sensing VYB. Okay.
Okay.
What he has given? Fault current lags the system voltage by how much? 90 degrees. So
90
this
degrees.
is the system voltage. Fault current lags the system voltage by 90 degrees. So IF will be in phase with VYB. So this is the CT current. Okay. CT current is what? IF. Okay. So flux phi SE will be in phase with IF only. Now, and he has given the impedance of the PT coil as 0.1 plus J0.1. This PT coil lags this voltage by 45 degrees because theta V that you can calculate is 45 degrees. Okay. Now the force is directly proportional to product of the two fluxes and sine of angle between those two fluxes. Okay. So here force or torque directly proportional. Torque is nothing but turning moment of force about an axis. Torque is nothing but what? Turning moment of force about an axis is nothing but torque. Okay. So here torque, maximum torque given as 10 Newton meter. This is nothing but maximum force or maximum torque. So this value angle between two fluxes is 45 degrees. We get.
Okay, sir. Got it, sir.
Okay. Ramachandran.
Sir, hello, sir.
Ask your doubt.
Sir, slide number 5, sir.
Slide number 5. What is your doubt?
Sir, in the third circuit, sir, in the third system, if the R5 is placed near the load, sir, we should consider it as which type of relay, sir? Either directional or
Whether you are
non-directional.
placing here or there, it will not have here. There is no need of a relay here actually because only this is load. No, it will not deliver any current.
Okay, sir.
Normal condition also it will observe the same current. Fault current also it will observe the same current.
Sir, but sir, the placement of the relay is depends upon the source or load, sir.
See, here there is no relay required. One relay is sufficient for this line. No, in this example he has shown here. Even if you place at the load side also, it will not have any discrimination. It is a non-directional relay only, because there will not be any change in direction of current from normal condition to fault condition.
Okay, sir. Thank you, sir.
Vikram,
15F.
what is your doubt?
Sir, how do we set the value like 10 to 20% or 110 to 120? Is it just
See
pre-decided?
here, listen here. During normal condition, there will be load current through the phases. Okay, but neutral current will not exist during normal condition. So generally the phase relay will have a set value of, suppose if the rated current is 100 amperes, we will have the set value of the relay of phase relay as 110 to 120% of that. But earth relay will not carry any current during normal operation. It will carry only the neutral current. Neutral current exists only during abnormal condition, that is fault condition. That's why the phase relay will have the set value of 110 to 120%, and earth relay will have the set value of 10 to 20%. Is it clear?
Yes, sir.
Okay, mute from yourself. Anil Kumar.
Good evening, sir.
Good evening, ask your doubt.
Hello.
Ask your doubt.
Sir, in 10F, sir.
In 9F. What is your doubt?
10F.
What is your doubt, sir?
Sir,
Huh?
in green counter, you said that the relay is nearer to the source is non-directional and the nearer to load is directional, sir. In this, how do you mark the direction of relay?
How do you mark the direction? Means this fault F1 is to be censored by R1 and R2. R2 should operate for the fault in this direction. Okay.
Then only we have to mark the direction.
Based on that fault only, we should mark the direction. That's all.
Sir, in 16F, sir.
Okay.
So next let's say for fault that line to line fault.
This one.
So the problem never explained it, sir.
This one.
Only phase relay and characterize it.
Huh?
Sorry, sir. Yes, sir. I did not
What is your doubt
think,
here?
sir. Thank you, sir. Sir, into
What is
line
your
to
doubt?
line fault, sir. Line to line fault.
Here there are three possibilities: RY, YB, and RB faults are three possibilities. So whenever line-to-line fault expressed, neutral current will not exist. So earth relay will not operate. So here, suppose if the RY fault takes place, if you plate one phase relay, that will sense. But if the fault is between Y and B, this first phase relay will not sense. That's why you should place the second phase relay here. Okay, you can place either in Y or B. There is no compulsion to place on B. So if you place between phase, suppose if you place in B, it will sense that fault. R and B also, these two relays will sense the fault. So we require two phase relays for sensing what? Line to line fault. Okay. Okay, mute from yours.
Good evening, sir.
Good evening.
So in page number 9F.
Page number
9F, sir.
9F. What is your doubt?
So have you got reliable protection as R1 and R2?
9F. How do you get reliable protection of R and R? When fault F1 takes place, which relays has to operate for that fault?
R1, R2, and
Then
R3.
that's what. No? R3 should not operate. If R3 operates, this line also disconnects. No.
Okay, sir. Okay.
If R3 operates, this particular line will be also disconnected. No.
Okay, sir.
Clear?
Yes, sir.
Okay. Okay. We'll take break, sir. Come back at 7:15. We'll come back after break. If my audio video is clear, I request the students to just raise the hand. If audio and video is clear, I request the students to just raise the hand. If audio video is clear, just wait a minute. I am answering. Okay, right. I think my audio and video is clear. Now let us start our discussion. So we have started about distance relays. We have started about distance relays. In distance relays, distance relays where to use? Distance relays where to use? Distance relays are used in protection of what? Transmission system. They are used in protection of transmission lines. So distance relay will be operated when the distance seen by the relay is more than its set distance or less than set distance. This is very important. Objective type procedure is less than the set distance or more than the set distance. Distance relay will be operated when the distance seen by the relay is operated, distance relay is less than the set distance. Okay, here distance is in terms of what? Impedance, reactance, and admittance. Here distance is in terms of impedance, reactance, and admittance. Okay. So distance is also known as reach of the relay. Distance is also termed as what? Reach of the relay. So distance relay is a what type of protection? Unit type of unit selectivity or non-unit selectivity? It is non-unit type protection. It is non-unit type protection. Okay. Now let us go for impedance relay. Now let us go for impedance relay. So before going to that impedance relay, one more point I need to give. In case of distance relays, both operating force and restraining force will be developed by the electrical quantities itself. In case of distance relays, both operating force and restraining force will be developed by what? Electrical quantities itself. My conclusion here is, in case of distance relays, both operating force and restraining force is developed by quantities itself. Both operating force as well as restraining force will be developed by the electrical quantities itself. What are the electrical quantities? Voltage, current, and directional element. Vi cos of phi minus tau. So what are the elements? Voltage, current, and directional element. We will use these three elements and develop the impedance relay, reactance relay, as well as admittance relay. Now let us come to the impedance relay. So now let us observe first normal condition. How the network behaves. Now observe this. This is a line that is to be protected. Let V be the voltage during normal condition. And during normal condition, what will be the current to the relay? Steady state current. During normal condition, what will be the current to the line? Steady state current will be through the line. So the impedance relay is placed here. Impedance relay is placed at this location. What will be the impedance observed by the relay during normal conditions? Steady state impedance. Okay. Steady state impedance is nothing but voltage by steady state current. Steady state current. This is the steady state impedance. So here, this is the set impedance of the relay. This will be the Z set of the relay. During normal condition, whatever the impedance that is observed by the relay is nothing but set impedance of the relay. Okay. Now, whenever the short circuit fault takes place, what happens? Now, let us observe. Due to fault, due to due to short circuit fault, short circuit fault. Due to short circuit fault, what happens? Now, let us observe. So, now let us consider. Let this bus voltage be B, and the relay is placed at this location, and the relay is placed at this location. When short circuit fault takes place, what happens? When short circuit fault takes place, what happens? What will be the current through the relay? What will be the current through the relay? Subtransient current. Subtransient current is nothing but fault current. Fault current, it is also known as what? Subtransient current. It is also known as subtransient subtransient current. It is nothing but a fault current. During fault, due to short circuit fault, what is the current observed by the relay? Subtransient current. Then the subtransient impedance observed by the relay is V by I subtransient. So due to short circuit fault, what is our observation? The subtransient current will be very high when compared to what? Steady state current. Subtransient current will be very high when compared to steady state current. When you compare subtransient current and steady state current, subtransient current will be very high. So as the subtransient current is very high, the subtransient impedance will be very less. So what is the impedance observed by the relay here? Subtransient impedance. Z subtransient is less than Z steady state. Z is steady state. So here Z steady state is nothing but Z set. That is the impedance setting of the relay. Impedance setting of the relay. So when will the impedance relay operates? When the impedance relay operates, whenever the impedance observed by the relay is more than its set impedance or less than the set impedance. When will the impedance relay operate? When the impedance relay will operate, sir. When the impedance relay will operate, whenever the impedance seen by the relay is more than its set impedance or less than the set impedance. This Z steady state is nothing but what? Z set. This is nothing but Z set. So whenever the impedance observed by the relay is less than the set impedance, impedance relay will be operated. So what is our conclusion here? So when when the impedance observed by the relay, when the impedance observed by the relay is less than the set impedance, when the impedance observed by the relay is less than the set impedance, impedance relay will be operated. Impedance relay is operated. Okay. So when will the impedance relay operates? Whenever the impedance seen by the relay is less than the set impedance. Okay. Now let us see how can we construct. This impedance relay. Now let us observe. Here I have said in distance relays, I have said that point. In distance relays, both operating force and restraining force will be developed by what? Electrical quantities itself. In case of distance relays, both operating force and restraining force will be developed by electrical quantities itself. Okay. Here, in case of impedance relay, operating force is due to current and restraining force is due to voltage. Okay. In case of impedance relay, operating force is due to current. Operating force is due to current. Operating force is due to current, and restraining force is due to what? And restraining force is due to voltage. So how do you are developing the operating force? Current quantity, and restraining force is due to voltage quantity. So F naught is due to current, and Fr is due to voltage, So I have already derived force is directly proportional to what? Square of the operating quantity. Force is directly proportional to square of the operating quantity. F naught is directly proportional to I square. So we can write F naught is equal to some constant K1 I square, and Fr is directly proportional to V square. Fr is equal to K2 V square. So now, how can we construct this impedance relay? Impedance relay can be constructed by using balanced beam type electromagnetic attraction type relay. Impedance relay can be constructed using balanced beam type electromagnetic attraction relay. Okay. Impedance relay can be constructed. Impedance relay can be constructed using balanced beam type electromagnetic attraction type relay. Electromagnetic attraction type relay. Now let us see how can we implement this impedance relay. We can be implementing this impedance relay by using what? Balanced beam type electromagnetic attraction type relay. Now let us see what do you mean by balanced beam type electromagnetic attraction type relay. Okay, what do you mean by balanced beam type electromagnetic attraction type relay? Now let us analyze. So there is a balanced beam like this, same as your physical balance that you will observe in your shops. So this beam is being balanced at this midpoint or central point, we can say. So this is core. Here you have one side you will be developing the operating force, and the other side you will be developing the restraining force. One side you will develop what? Operating force, and the other side you will develop the restraining force. Here this is the operating coil and this is the restraining coil. So now let this be restraining coil, and this is the operating coil. Okay. Operating coil. On this operating coil side, we will connect a relay contact. Here, what do you place? A relay contact will be placed. A relay contact is placed, and it is connected to trip circuit. And it is connected to trip circuit. Okay. Now, here operating force is due to what? Current. Operating force is due to current. Operating force is due to current. That's why excite this operating coil with CT. Excite with this operating coil with CT. Operating force is due to current. Excite this operating coil with CT. And restraining force is due to voltage. Excite with PT. Restraining force is due to voltage. Excite with PT. Okay. Now, what happens? During normal condition, the balance will be in this position. The balance will be in this position. But when short circuit fault takes place, what happens? Current magnitude increases. So force on this CT side increases. So when the voltage magnitude decreases, so the force on this restraining side will decrease. But force on the operating side will increase. So the balance will be moved like this. The balance will be on this side downward. So this relay contact will close the trip circuit, and the relay will operate. Here, operating force is due to current, and restraining force is due to voltage. When short circuit fault takes place, what happens? Current magnitude increases and voltage magnitude decreases. So the force on the operating coil side increases. So the relay contact will track it downward, and this will close the trip circuit, and the relay will operate. On the other side, the force will be reduced. Okay, understood my point? The balance will be under this condition, normal position. But when short circuit fault takes place, this relay contact will close the trip circuit, and the relay will operate. Okay. Now let us analyze. I will write that point here. When short circuit fault takes place, when short circuit fault takes place, current magnitude increases. Current magnitude increases. And voltage magnitude current magnitude increases and voltage magnitude decreases. Current magnitude increases and voltage magnitude decreases. So what happens? So the operating force increases. Operating force increases. So the relay contact close the trip circuit. and the relay operates. And the relay operates. So this is how. So this is how a balanced beam type electromagnetic attraction type relay operates. So this is what balanced beam type, balanced beam type, beam type electromagnetic, electromagnetic, electromagnetic attraction type relay, attraction type relay. So understood this point? Okay. Now let us mathematically analyze. Now let us mathematically analyze this balanced beam type electromagnetic attraction type relay. How can we mathematically analyze this balanced beam type electromagnetic attraction type relay? Now let us go for that. So here operating force is due to what? Current. So analysis of that operating force is what? K1 I square, and resistance force is due to voltage, that is K2 V square, K2 V square. For relay operation, what condition must be satisfied? For relay operation, what condition must be satisfied? For relay operation, what condition must be satisfied, sir? Operating force must be greater than resistance force. F naught should be greater than F naught, Fr. When operating force is greater than the resistance force, when operating force is greater than the resistance force, the relay operates. So for that, what condition must be satisfied? Now let us observe. K1 I square should be greater than what? K2 V square. When K1 I square is greater than K2 V square, the relay will operate. So when K1 by K2 greater than V by I whole square, the relay will operate. When K1 by K2 greater than V by I whole square, the relay will operate. So under root of K1 by K2 is greater than what? V by I, the relay will operate. So here under root of K1 by K2 is greater than voltage by current is nothing but impedance. Or we can also write this equation as when Z is less than under root of K1 by K2, the relay operates. So this under root of K1 by K2 is known as the set value of the relay, set value of relay, set value of the relay. So here we have mathematically proved that, whenever the impedance seen by the relay is less than the set impedance, whenever the impedance seen by the relay is less than the set impedance, the relay is operating or not? Yes. So impedance relay will be operated. Impedance relay is operated when the impedance seen, when the impedance seen is less than set impedance, whenever the impedance seen is less than set impedance, the impedance relay will be operated. Now let us go for the boundary condition analysis. That is nothing but at verge of operation, what will be the situation? At verge of operation, let us analyze the system. At verge of operation, what is the operating force? K1 I square. What is the restraining force? K2 V square. At verge of operation, what happens, sir? Operating force is equal to restraining force. Operating force is equal to restraining force. At verge of operation, what happens? F naught is equal to Fr, means K1 I square is equal to what? K2 V square. K1 I square is equal to K2 V square. What do you get here? K1 by K2 is equal to V by I whole square. V by I whole square you got. Okay. So from this, what you can write here? V by I is equal to under root of K1 by K2. Under root of K1 by K2. So from this, what is the relation for? Let this be equation A. Let this be equation A. From this, what is I value? I value, how to write? V into under root of K2 by K1. Can you write it or not? Under root of K2 by K1. So if you plot the characteristic between voltage and current, what do you get? This is in the form of y is equal to mx. This is in the form of y is equal to mx. So this curve shows like this. So in which region the relay operates? This is the operating region. This is the operation region, and this is the non-operating region. Okay. So here there is no minimum current requirement or minimum voltage requirement. Okay. So whenever the current falls under this condition, the relay will operate. Minimum voltage requirement is removed. Even if the voltage is zero, if the current is existing, the relay is operating or not? The relay is operating. So there is no dead zone in relay operation. So there is no dead zone. dead zone. Okay, there is a dead zone in a overcurrent relay that we have discussed in the last class, no? But there is a no dead zone in relay operation. There is no dead zone in relay operation. In case of water, distance relays, the dead zone problem is overcome or not? The dead zone problem is overcome. Okay, so there is no dead zone problem in relay operation. But in case of overcurrent relays that we have discussed, whatever relay, there is a dead zone in the relay operation. Yes or no? Because there you get inverse characteristic. There you got inverse characteristic. But here you got linear characteristic. Here you got linear characteristic. Understood my point? So now what do you get here? Now equation A implies what? V by I. Equation A gives what? V by I is under root of what? V by I is under root of K1 by K2. Under root of K1 by K2. Okay. V by I is equal to under root of K1 by K2. Now V by I is nothing but what? Impedance. Z is equal to under root of K1 by K2. Z is equal to under root of K1 by K2. Now let us observe the impedance triangle. This is the resistance, reactance and impedance. Resistance, reactance and impedance. So what is the Z value? Under root of what? R square plus X square. Under root of R square plus X square. Z is equal to under root of R square plus X square. So what you got here? Z is equal to under root of K1 by K2. So Z is what here? Under root of R square plus X square. R square plus X square is equal to under root of K1 by K2. Under root of K1 by K2. So what do you get here? R square plus X square is equal to under root of K1 by K2 whole square. Under root of K1 by K2 whole square. Under root of K1 by K2 whole square. Okay. So what you got? What is this equation represents? What is this equation represents? So if you plot this equation in Rx plane, or if you plot this equation in Rx plane, R Jx minus R minus Jx, R plus Jx minus R minus Jx. So if you plot this equation in Rx plane, what you get? This equation is in the form of x square plus y square is equal to R square. X square plus y square is equal to R square. So in xy plane, that represents a circle with centroid origin. Here also what you get? You will get a circle with centroid origin. This is the representation of this characteristic of impedance line Rx plane. So this radius is what? Under root of K1 by K2. Under root of K1 by K2. When the relay is operating here, when the relay is operating, when the impedance seen by the relay is less than the set impedance or greater than the set impedance, whenever the impedance seen by the relay is less than its set value, the relay is operating. So operating region is inside the circle or outside the circle. So the operating region is inside the circle or outside the circle. The operating region is inside the circle. So whenever the impedance observed by the relay is within the circle, the relay operates. So the operating region is inside the circle. Outside the circle, it is non-operating region. Outside the circle, it is non-operating region. So what is the characteristic of impedance relay in Rx plane? It is a circle with centroid origin. Okay. So we have came to a conclusion that the characteristic of impedance relay, the characteristic of impedance relay in Rx plane is a circle with center at origin. The characteristic of impedance relay is a circle with center at origin. So what is the operating region and what is the non-operating region? Operating region is whenever the impedance observed by the relay falls within the circle, the relay operates. If it is outside the circle, the relay will not operate. The operating region is if the impedance observed by the relay, if the operating region is inside the circle. Okay, operating region is inside the circle. If it is outside the circle, it is non-operating point. Okay, so we have discussed about impedance relay. I will repeat this impedance relay. Very important, sir. Distance relays are very important from protection point of view. Now let us analyze. Impedance relay means what? When impedance relay will be operated whenever the impedance seen by the relay is less than the set impedance. What is the set impedance? During normal condition, what will be the impedance observed by the relay? It is a steady state current. Okay, I Z steady state is V by I steady state. That is Z set. This is the set impedance of the relay. But whenever the short circuit fault takes place, the fault current flows through the line. That fault current is nothing but subtransient current. That is the first cycle RMS value of current is nothing but what? Subtransient current. The subtransient current will be very high when compared to what? Steady state current. Subtransient will be very high when compared to steady state current. Okay. So as the current is very high, the impedance, subtransient impedance will be less when compared to what? Steady state impedance. So whenever the subtransient impedance is less than the set impedance, the relay observed, then the relay will operate. So whenever the impedance seen by the relay is less than its set impedance, impedance relay will be operated. So in case of impedance relay, how the operating force and restraining force are developed? How the operating force and restraining force are developed in case of impedance relay? In case of impedance relay, operating force is due to what? Current. Operating force is due to current. And the restraining force, how you are developing? Restraining force is developed because of voltage. Restraining force is developed because of what? Voltage. So we have already derived. Force is directly proportional to what? Force is directly proportional to operating quantity square, square of the operating quantity. Here current and here it is voltage. Directly proportional to I square, directly proportional to V square that we get. K1, K2 are the constants. So how do you construct this impedance relay? How do you construct the impedance relay? How can you construct the impedance relay? Impedance relay can be constructed using balanced beam type electromagnetic attraction type relay. How do you construct the impedance relay? Impedance relay can be constructed using what? Balanced beam type electromagnetic attraction type relay. So this is a balanced beam type electromagnetic attraction type relay. Here there will be a physical balance type structure. So one is operating force and the other develops the restraining force. As the operating force is due to current, excite this operating coil with current CT, and restraining force is due to voltage, excite this restraining coil with PT. So whenever the short circuit fault takes place, what happens when short circuit fault takes place? Current magnitude increases. So force on this side will increase and this relay contact will close the trip circuit. And automatically when short circuit fault takes place, voltage decreases. So restraining force will be reduced. Okay. So now we have make a point here. When short circuit fault takes place, current magnitude increases and voltage magnitude decreases. So operating force increases. So relay contact will close the trip circuit and the relay will operate. Now here mathematical analysis that I have done for the impedance relay. Operating force is due to what? Current. Restraining force is due to voltage. F0 is equal to K1 I square. Fr is equal to K2 V square. For relay operation, what condition must be satisfied? Operating force must be greater than restraining force. For relay operation, what condition must be satisfied? Operating force must be greater than restraining force. So we have got a condition that the impedance, whenever the impedance observed by the relay is less than this set value, the relay will operate. Okay. So let us consider the boundary operation, that is at verge of operation. At verge of operation, how the relay behaves. At verge of operation, how the relay behaves, let us observe here. So F0 is equal to what? K1 I square. Fr is equal to K2 V square. At boundary condition, both the forces are equal. At boundary condition, both the forces are equal. So what you get? You will get this equation. So if you plot the current and voltage characteristic, you will get a linear equation. That is Y is equal to mx form. Okay. So operation region is this one, non-operating region is this one. So even if the voltage is zero, current is existing, then the relay is operating or not? Yes, sir. So the dead zone problem has been removed. So there is no dead zone in relay operation. In case of overcurrent relays, that we have discussed, there is a dead zone problem. Okay. So now from equation A you can plot this, and Z is under root of R square plus X square. So you got this equation. So if you plot this characteristic equation, characteristic of impedance relay on Rx plane is nothing but impedance plane. So what is the characteristic of impedance relay in Rx plane? It is a circle with center at origin. What is the operating region? Inside the circle. Outside the circle it is non-operating region. Outside the circle it is non-operating region. So radius is the set value. Radius is the set value of the relay. Okay. So operating region is inside the circle. Okay. Understood my point? Understood or not? Okay. Now, here operating force is due to current and restraining force is due to what? Voltage. Operating force is due to current and restraining force is due to what? Voltage. That's why we can call this relay as voltage restrained over current relay. We can also call impedance relay as what? Voltage restrained over current relay. Impedance relay is also known as impedance relay is also known as voltage restrained overcurrent relay, overcurrent relay. Impedance relay is also known as what? Voltage restrained overcurrent relay. Impedance relay is also known as voltage restrained overcurrent relay. Why? Operating force is due to current and restraining force is due to voltage. That's why it is known as voltage restrained overcurrent relay. Now let us observe whether it is a directional relay or a non-directional relay. How do we observe? Now let us observe that this section of relay, this section is to be protected by an impedance relay placed at this location. An impedance relay is placed at this location, and we need to protect this section of line. So what you will do? We will plot the characteristic of impedance relay on Rx plane. We'll plot the characteristic of impedance relay on Rx plane. What is the characteristic of impedance relay on Rx plane? It is a circle with centroid origin. Operating region is inside the circle. Non-operating region is outside the circle. Non-operating region is outside the circuit. So what happens when short circuit fault takes place? When short circuit fault takes place, what happens? When short circuit fault takes place, what happens? This is the line impedance. This is the line impedance. This is the ZF1, or you can take it as ZF1. ZF1. Okay. So this ZF1 is within the operating region or outside the operating region? Within the operating region. So that will operate or not? That will operate. So where that ZF1 operates? So that ZF1 is here. That is ZF1 is here within the operating region, and the relay is operating. So it is less than the set impedance. No, this is the total. This is the total Z set. So this is the Z set. So impedance observed is less than the set impedance or more than the set impedance? Less than the set impedance. So the relay operates or not? Relay operates for the fault. Relay operates for fault. For fault. Relay operates for fault. Now if you consider the upstream section of the line, what happens if the fault is taking place in the upstream section of the line? If there is upstream line is existing, and if the fault takes place, here. Now let the short circuit fault is taking place at this location. Now here let ZF2 be the impedance. Observed by the relay. So how do you calculate ZF2? When you compare to this ZF1, here the current direction is reversed or not? Fault is on the other side. V by minus I. So you can write it as minus of V by I. So V by I is nothing but impedance. So minus of Z, that is nothing but R plus Jx. So we can write it as minus R minus Jx. So this ZF2 falls in which region? In the third quadrant, because in the third quadrant both are negative. So ZF2 falls in third quadrant. So this fault is also sensed. Relay operates for the fault. That means relay is sensing forward faults as well as reverse faults. Relay is sensing forward faults as well as reverse faults. So it is a directional relay or a non-directional relay. So it is whatever the forward region that has been set. This is the forward region, and whatever the forward region that has been set, and the reverse region is also observed or not? It is also observing what? Reverse region. Whatever the forward region that has been set, reverse faults also it is sensing. Reverse faults also it is sensing. Forward faults it is sensing both forward faults and reverse faults. So the relay is directional relay or a non-directional relay? It is a non-directional relay. Okay. Impedance relay is directional or non-directional? So what is your answer? Question is, impedance relay is directional or non-directional relay? Non-directional relay. Impedance relay is non-directional relay or a non-directional relay? That is the question here. So what is your answer? It is sensing both forward faults as well as reverse faults. So it is not sensing any direction. So it is a non-directional relay. So as impedance relay is sensing both forward faults and reverse faults as the impedance relay is sensing both forward faults and reverse faults, it is a non-directional relay. Non-directional relay. It is a non-directional relay. So here important observation is impedance relay is a non-directional relay. Okay, I think you got the idea. It is sensing both forward faults as well as reverse faults. It is not sensing any direction. That's why it is a non-directional relay. Okay. Now, where to use? What is the application of this impedance relay? We have transmission lines or of transmission lines are classified into three types. No, short transmission line, medium transmission line, short transmission line, medium transmission line, and long transmission line. The transmission lines are classified into three types: short transmission line, medium transmission line, and long transmission line. Where to use this transmission lines? Sorry, where to use the impedance relay? Which line it is protected? Impedance relay is used in protection of medium transmission lines along with a directional element. So impedance relay impedance relay is used in protection of medium transmission lines. Impedance relay is used in protection of what? Where to use this impedance relay? Impedance relay is used in protection of medium transmission lines. Impedance relay is used in protection of medium transmission lines along with directional element because transmission network is interconnected or radial is interconnected. So as transmission network is interconnected, we can impedance relay is used where medium transmission lines along with a directional element. So what do you do? This is the impedance relay. Impedance relay. This impedance relay is coordinated with a directional element. Here, directional element. Here you will be coordinating these two. Impedance relay is coordinated with what? Directional element. Until this directional element senses, this relay is not operated. So here we are coordinating the directional element along with the impedance relay for protection of what? Medium transmission lines. What is the application of this impedance relay? Is used in medium transmission lines. Okay. So what is the characteristic of impedance relay in RX plane? What is the characteristic of impedance relay in RX plane? It is a circle with centroid origin. Now, whenever you coordinate this with a directional element, so the directional element characteristic is like this. So it will operate only for the forward faults. So this will be the operating region. So which region the relay operates? Only in this region the relay will operate. That means it will sense only the forward faults. Whenever you are setting it as a directional element with impedance relay. Okay, understood my point here? So this is about impedance relay analysis. Now let us study one peculiar characteristic of this relay. So what is that behavior of the impedance relay? Now let us observe behavior of the impedance relay for faults at different sections of the line. We will study the behavior of impedance relay for faults at different sections of the line. Okay. Now let us consider this line is to be protected by the impedance relay placed at this location. Let V be the voltage at this bus, and what we will do, we will measure the set impedance. This is the Z set, and we will plot the characteristic of the relay in RX plane. So what is the characteristic of impedance relay in RX plane? It is a circle with centroid origin. So operating region is inside the circle. Non-operating region is outside the circle. So So we will measure the set impedance and we will measure the operating point and non-operating point. Now let us consider faults at different sections of the line. Now let us consider faults at different sections of the line. In case one, first we will consider short circuit fault nearer to the relay end. Short circuit fault near to relay end. Near to relay end. Near to relay end. Short circuit fault is taking place near to relay end. So this is the line which is to be protected. V is the voltage at this pass. Relay is placed at this location. So when short circuit fault takes place, at this point, what happens? The fault impedance let up to this point is ZL1. Line impedance up to that point is ZL1. So the fault will complete its path in what direction? The fault will complete its path in this direction. The fault current will complete its path to the nearest neutral that has been grounded in this way. Yes or no? In this direction, the fault will complete its path. So what happens? In addition to line impedance, here earth resistance is also added up or not? Earth resistance is added up or not? Earth resistance will be added up or not? This is the earth resistance that is added up to the line impedance. So what is the behavior of the relay due to the addition of that earth resistance? Now let us analyze. This is resistance and reactance. This is minus R. This is minus Jx. So what is the operating region is inside the circle, non-operating region is outside the circle. So ZL1 is the line impedance. ZL1 is the line impedance. When earth resistance is added up, so the net impedance observed by the relay will be within the operating region or non-operating region, is within the operating region. So the relay operates or not? Relay operates for the fault. Relay operates for fault. Relay operates for fault. So impedance observed by the relay here is ZL1 plus earth resistance. ZL1 plus earth resistance. Even though earth resistance is added up, the impedance observed by the relay is within the fault or outside, within the operating region or not? Within the operating region. So the relay is operating for the fault or not? So the relay is operating for the fault or not? Operating for the fault. Okay. Now let us consider case 2 where the short circuit fault is taking place at the far end of the relay. Case 2 is short circuit fault is at the far end of the relay. Short circuit fault is at far end of the relay. Far end of relay. Short circuit fault is taking place at the far end of the relay. If the short circuit fault is taking place at the far end of the relay, what will be the analysis? So let V be the voltage at this bus. Relay is placed at this location. So when the short circuit fault is taking place at the far end of the relay, what happens? This is the line impedance. Let it be ZL2. So in addition to line impedance, what happens? The fault current will complete its path in this direction. Yes or no? In this direction, the fault current will be circulated. So here, in addition to line impedance, this earth resistance is also added up. Earth resistance is also added up. Now what happens? What is the observation? Whether this relay senses the fault or not? Whether the relay senses the fault or not? Now let us observe. So the characteristic of the relay is circle center at origin. Operating region is inside the circle. Non-operating region is outside the circle. So ZL2 is the line impedance. So this is the ZL2 is the line impedance. So whenever the earth resistance is added up, the net impedance observed by the relay, is falling outside the circle. So here the impedance observed by the relay is what? Impedance observed by the relay is ZL2 plus earth resistance. So the net impedance observed by the relay is falling outside the circle. So the relay will fail to operate or not? So the relay will fail to operate. Relay fails to operate. Relay fails to operate. Relay fails to operate. Here, even the distance seen by the relay is less than the set distance or greater than the set distance. Distance seen by the relay is less than the set distance. Distance seen by the relay is less than the set distance. Distance observed by the relay is less than the set distance. But the distance relay is failing to operate or not? This problem in distance relays is known as underreach problem. This is known as what? Just wait, sir. This problem in distance relays, sorry, here. It is known as what? Underreach problem in distance relays. It is known as what? Underreach problem in distance relays. Distance relays. This is known as what? Underreach problem in distance relays. So how do you define underreach problem? So if the distance relay fails to operate, even when the distance seen by the relay is less than its set distance, if the distance relay fails to operate, here the distance relay is failing to operate even when the distance seen by the relay is less than the set distance or greater than the set distance, even when the distance seen by the relay is less than the set distance. So that is known as what? Underreach problem in distance relays. That is known as underreach problem in distance relays. How do you write underreach problem in distance relays? Underreach problem means what? If distance relay fails to operate, if distance relay fails to operate when the distance relay fails to operate even when the distance seen by the relay, even when the distance seen by the relay is less than the set distance. If the distance relay fails to operate even when the distance seen by the relay is less than the set distance, that is known as what? If the distance relay fails to operate even when the distance seen by the relay is less than the set distance, it is known as underreach of distance relay. It is known as what? Underreach of distance relay. Is the underreach problem present throughout the section of line? No. Here, the relay is having sensitivity for the faults which are taking place near to relay end. Relay is sensing the faults which are taking place near to relay end. It is sensing the faults which are taking place near to relay end and losing the sensitivity for the faults which are taking place at the far end. That means underreach problem is not present throughout the section of line. Underreach problem is not present throughout the section of line. Relay is sensing the faults which are taking place near to relay end, and relay is losing sensitivity for the faults which are taking place at the far end. Relay is sensing the faults which are taking place near to relay end and losing the sensitivity for the faults which are taking place at the far end. Okay, what is your observation? Underreach problem is not present for the entire section of line. Relay is sensing the faults which are taking place near to relay end and losing sensitivity. Relay is sensing the faults which are taking place near to relay end and losing sensitivity for the faults at far end. Relay is sensing the faults which are taking place near to the relay end and losing the sensitivity for the faults which are taking place at the far end. Why the underreach problem is coming into picture? What is the reason for underreach problem? Here, underreach problem is maybe due to effect of earth resistance or arc resistance. Underreach problem is maybe due to the effect of earth resistance or arc resistance. So we have seen the effect of earth resistance. What do you mean by arc resistance? What do you mean by arc resistance? Now let us observe. Now let us observe here. So here, if you consider a transmission line, you observe a transmission line, there will be a line supporter, line supporter, line supporting structure will be there. There will be an earth wire or ground wire, earth wire or ground wire running from the top of the tower, and there will be a cross arm connected to this line supporter. This is nothing but cross arm connected to this line supporter, and to the end of this cross arm, here you have the insulator. Here you have the insulator. This is nothing but this is the insulator. And to the other end of the insulator, what is connected? Power conductor. This is the conductor. So to protect this insulator from over voltages, here we will use a guard ring as well as here we will be maintaining a spark gap arrangement. Here we will be maintaining a spark gap arrangement. Here you will be connecting the arcing rod. This is nothing but arcing rod. So whenever this line experiences any over voltage, instead of making the flashover of insulation, instead of making the flashover of this insulator, what happens? The gap between this arcing rod and guard ring will conduct. Gap between the arcing rod and guard ring will conduct. So how that flashover takes place? Like this. Whenever the flashover takes place, there is a formation of arc. Here there will be a formation of arc formation takes place. What happens due to over voltage? So this will create a short circuit path like this. Whenever the arc formation takes place, it will create a short circuit path like this. Yes or no? So there will be a short circuit path. So this arc is modeled with arc resistance. This arc is modeled with what? Arc resistance. In addition to the line impedance, this arc resistance will be also added up. In addition to the line impedance, arc resistance will be also added up. So that may result in the impedance absorbed by the relay outside the circle. And the relay may fail to operate. Okay. So why the underreach problem and underreach problem coming into picture? Underreach problem is maybe due to the effect of earth resistance or arc resistance. Underreach problem is maybe due to the effect of earth resistance or arc resistance. So how do you overcome this how do you overcome this underreach problem? Can you allow underreach problem? No. So how do you overcome this underreach problem? Underreach problem can be overcome by using zonal protection scheme. Underreach problem can be overcome by using zonal protection scheme. Here we will be using what? Underreach problem can be overcome by using which scheme? Zonal protection scheme. Now let us see again what do you mean by underreach problem. So for understanding underreach problem, just wait. I have considered a line which is to be protected, and I have measured the set impedance. I have plotted the characteristic of that relay in this RX plane. So what is the characteristic of the impedance relay in RX plane? It is a circle with center at origin. Operating region is inside the circle. Non-operating region is outside the circle. Okay. So in case 1, what I have considered? Short circuit fault nearer to the relay end. So in addition to line impedance, this earth resistance or arc resistance is added up. Even that earth resistance or arc resistance is added up, the net impedance absorbed by the relay is falling within the circle. So the relay operates, no issue. But if you consider fault at the far end of the relay, if the fault is taking place at the far end of the relay, what happens? When the fault is taking place at the far end of the relay, what happens? In addition to line impedance, earth resistance will be added up. So when earth resistance is added up, the net impedance observed by the relay will be falling outside the circle. So the net impedance observed by the relay is falling outside the circle. So the relay is failing to operate. So the relay will fail to operate. Understood my point? So the relay fails to operate if the fault is taking place far end of the relay. So here the distance observed is less than the set distance or greater than the set distance. The total distance is this one, but the distance observed is less than the set distance, but it is failing to operate. This is known as what? Underreach problem. What do you mean by underreach problem? If distance relay fails to operate, even when the distance seen by the relay is less than its set distance, it is known as what? Underreach of the relay. It is known as underreach of distance relay. Okay. Underreach problem is not present for the entire section of line. Underreach problem is not present for entire section of line. So relay is sensing the faults which are taking place. Relay is sensing the faults which are taking place near to relay end. If the fault is taking place near to relay end, relay is sensing, and it is losing the sensitivity for the faults at far end. If the fault is taking place at the far end, it is losing the sensitivity. So underreach problem is maybe due to the effect of earth resistance or arc resistance. Underreach problem is maybe due to what? Effect of earth resistance or arc resistance. So underreach problem, how do you avoid? By using zonal protection scheme. Here arc resistance means here arcing rod and gartering is used to protect the conductor from over voltage. So this insulator is protected from over voltage. If over voltage takes place, insulation may damage. So to protect that, this arrangement is used. Spark gap arrangement is used. So when over voltage is experienced, this gap gets conducted. And insulator is protected from flashover. Okay. Now this is about underreach problem in distance relays. So in today's class, what we have discussed, sir? So I will just revise what we have discussed. Just listen. So in today's class, we have discussed how to identify whether the relay is to be directional or non-directional. So the first question is how to identify relay is directional or non-directional. So what do you need to do? First step, you identify the normal current directions in the relays. Okay, normal current directions. Then in step 2, what do you need to do? Consider faults in different sections and observe the direction of currents. Consider faults in different sections and observe the direction of currents. If there is no change, it is a non-directional relay. If there is a change, then it is a directional relay. Okay, we have solved 2 different problems, and we have made a conclusion. What is our conclusion? The relays which are placed nearer to the source end are what? Non-directional relays, and the relays which are placed nearer to the load end are what? Directional relays. And then we have gone for the parallel lines. Even in parallel lines, there will be a change in direction of current observed by the relays from normal condition to fault condition. So if there is a change in direction of current, that is a directional relay. Otherwise, it is a non-directional relay. Okay. So here, timing sequence also to be calculated. Some problems may be asked. What is the timing sequence? 4 different options can be framed. Which option is correct? Okay. So that is about parallel lines that we have discussed. Okay. Next, we have gone for ring-main system. Ring-main system. In this ring-main system, the relays which are connected nearer to the source are what? Non-directional. Relays which are connected nearer to the load are directional. Here R2, R3, R4, R5, R6, R7 are what? Directional relays. R1, R8 are non-directional relays. Okay. Now we have got the timing sequence for all the 8 relays by considering faults in 2 different sections. Next, what we have done? We have gone for discrimination of grounded faults. That means how to identify whether the fault is a grounded fault or ungrounded fault. So how do you identify? We need to use an earth relay along with phase relay, because grounded fault will create a neutral current. That neutral current can be sensed by what? Earth relay. Okay. So set value of phase relay will be around 110 to 120%. Earth relay will be 10 to 20%. So when grounded fault takes place, earth relay will operate first. So if the trip action observed by the earth relay means, it shows that it is a grounded fault. If the trip action is observed by the earth relay means, it shows it is a grounded fault. So how many minimum number of phase relays and how many minimum number of earth relays are required for complete protection of the system? Minimum of 2 phase relays and minimum of 1 earth relay is required for complete protection of the system against any type of fault. After that, we have solved the problems given in your CRO. Then I have gone for distance relay. Distance relay is used in protection of what? Transmission lines. Distance relay will be operated when the distance seen by the relay is less than the set distance. Okay, here distance is also known as what? Reach of the relay. It is a non-unit type protection scheme. Okay, in case of distance relays, operating force and restraining force. In case of distance relay, operating force and restraining force will be developed by what? Electrical quantities itself. Okay, impedance relay. First, I have considered impedance relay. When the impedance observed by the relay is less than the set impedance, the impedance relay will be operated. When the impedance observed by the relay is less than the set impedance relay will be operated. So when short circuit fault takes place, what happens? Impedance observed is subtransient impedance. It will be less than the set impedance or steady state impedance, and the relay will be operated. So here, how we are developing the operating force and restraining force? Operating force is due to what? Current, and restraining force is due to what? Voltage. Operating force is due to current, and restraining force is due to voltage. Impedance relay can be constructed by what? By using balanced beam type electromagnetic attraction type relay. Balanced beam type electromagnetic attraction type relay. As the operating force is due to current, this coil is excited with CD, and restraining force is due to voltage. This coil is excited with PT. Okay? So when short circuit fault takes place, what happens? The force on this side will be increased. So this way, this side it will experience a pull downward. So this relay contact will close the trip circuit like this. This relay contact will close the trip circuit, and the relay will operate. Okay. So mathematical analysis we have done here. What is your observation? When Z is less than under root of K1 by K2. This under root of K1 by K2 is the set value of the relay. Relay will be operated. And we have considered the boundary operation. And we got the VI characteristic. It is a linear. So even if the voltage is zero, current is existing means the relay is operating. So the dead zone problem is overcome or not. So the dead zone problem is avoided. The dead zone problem is avoided here. So, and we have plotted the characteristic of impedance relay. What is the characteristic of impedance relay in RX plane? It is a circle with center at origin. Whenever the impedance observed by the relay is within the circle, the relay will operate. If it is outside the circle, the relay will not operate. Okay. So impedance relay is also known as what? Voltage restrained over current relay, because operating force is due to current and restraining force is due to voltage. Where do you use? Whether it is a directional relay or a non-directional relay? It is a non-directional relay. It is sensing both forward faults as well as reverse faults. It is sensing both forward faults and reverse faults. So it is a non-directional relay. And impedance relay is sensing both forward faults and reverse faults. So it is a non-directional relay. Where to use? What is the application of this relay? Impedance relay is used in protection of what? Medium transmission lines along with a directional element. So this black line is the directional relay element characteristic. Okay, only in this region the relay will operate. So this portion is removed from operation. So under which problem just now we have discussed. So now I will open the doubt session. If anyone has doubts, now you can ask. So just wait, I am lowering all your hands. So if you have doubt, you can raise your hand and you can ask, sir. Kranti Kumar.
Sir,
Kranti Kumar.
sir, at what distance from relay will it be lose its sensitivity, sir? Sir, sir,
Ask your doubt.
sir, at what distance from relay will it lose its sensitivity, sir?
That depends on the type of the relay.
For a given distance, at which
That's what I am saying. No, that depends on. We have still two more relays are there: reactance relay and admittance relay. Based on that, we will say which relay has that. We will discuss in the further classes about that.
sir, yesterday's class doubt,
What is your doubt?
sir, are that 90 degrees connection, 60 degrees connection are applied only to whatever relay without shaded band, sir?
That shading band is not required, sir. Only in some special case, if you want that VI cos phi relation, then only we will use that. That is not regularly used.
Okay, sir.
Without shading band only we will be using. Yeah.
Okay, sir.
That have given relation because to explain you about that magnitude of current and phase.
Okay, sir.
Pallavi.
Sir, in 20F.
20F. Say your doubt.
Sir, in that triple line to ground fault, how this neutral current is 0?
Because this is a balanced fault, sir. Whenever the current magnitudes are equal and the phase displaced by 120 degrees, if you add those all the currents, it will be 0. So there will be no neutral current.
Okay, sir. Thank you.
Okay. Bhavani.
Good evening, sir.
Good
Sir,
evening.
16F slide, sir.
16F. Ask your doubt.
Sir, let us assume a three-phase system with three phase relays and one ground relay, sir.
Okay.
Sir, if a LG fault occurs, how many relays will be activated, sir?
Only one relay. Actually, because earth relay will have more sensitivity, no? First earth relay will operate.
Then after one phase relay will be also activated, right, sir?
If that is not operating, that phase relay will be also operated.
Okay, sir. Sir, another question, sir. The day before yesterday, in one problem, the time of operation of a relay is 1.5 seconds, sir.
Okay.
Sir, if it took 1.5 seconds, the fault before the relay initiate the action, the fault current will be enter the entire system, sir. Like 1.5 seconds means it is a very long time.
I have given that example, I think. That is the example. There I have taken the timing, no? That's what.
Yes, sir, but the fault current will take some minute seconds to enter the system, now, sir. If it take 1.5 seconds to activate. Hello.
Which problem I am not getting? What is that problem statement? Can you read out?
1 minute, sir. 1 second. Sir, in day 2, in a radial system is protected by overcurrent protection scheme using CT ratio some 400 by 5 and relay setting is 140% of full load current. 3 questions given, sir. In A, pickup current of the relay. At last, table given.
No issue. There for PSM of something, I have given the time as 1.5 seconds, sir.
Yes, sir. Actual time of operation is 1.5.
Okay. No issue, sir. That depends on the location of fault. Suppose if the fault is taking place very near to source, there will be using instantaneous operation. Suppose you take the fault on the distribution line. If you take the fault on the distribution line, it will not be more severe. Okay. But if you take the fault on the 400 kV network or 700 kV, 750 kV network, it will be more severe. There the time of operations will be very less.
Okay. In practical, the time is different, right, sir?
That is different, sir. Only for analysis that I have considered.
Sir, in 20F.
This today's class. Huh?
Yes, sir. Yes, sir. Today's class.
Okay. What is your doubt?
So for LL faults, why the number of usage of PR are 3 now, sir? Why it is 2? 2 number
LL
of
fault. Here,
yes,
how many possibilities are there for LL fault? 3 possibilities: RY, YP, PR. Okay.
yes, sir.
Is or no?
Yes, sir.
So when RY takes place, one phase relay is sufficient because the same fault current circulates in these 2 phases. Okay.
Yes, sir.
Understood my point? And
yes.
if you are using only this phase relay, if YB is short circuited, then this first phase relay will not sense. That's why I've kept one more phase relay here. So this YB is also sensed by that. Now, if R and B, then also the phase relays are sensing the fault. So minimum of 2 phase relays are required for LL fault.
Okay, sir. I understood, sir. Sir, in today's class, the radial network before ringman system, some radial network you have given.
Interconnected only. Today's I have not taken any radial.
The,
This is
no, sir.
interconnected, no?
Before ring main system. 2 parts are
Before
there.
ring main. This one, huh?
No, sir. 2 parts are there. R1, R2 in one path and R2, R3 in another. Yes, sir. This one.
This one, huh? Parallel
Yes.
paths. This is parallel lines. What is your
Parallel.
doubt?
Sir, if for F1 fault, how R3 is sensing, sir? R1, R2,
So, in
R3.
this, so one is in this direction, okay?
Okay.
And the other is in this direction. Okay.
Okay. Okay, sir. I understand. Thank you, sir. Thank you, sir.
Okay, right. Mute from you. B. Sai Charan.
Hello, sir.
Ask your doubt.
Sir, generally we will have the neutral point in a only distribution system, no, sir.
No, not like that. Even in transmission also, star grounded transformer will be there. No? Transformer will be grounded even in transmission system. No, not like that.
Okay.
Okay. Are you there?
Okay, sir. Clarified.
Okay, right. Vishnu.
Sir, I have 2 doubts. One in 9F, sir.
9F. Yes, wait.
Sir, in this thing regarding the sensed by R1, R2, R3, when fault F1 occurs, sir, this current from R3 is flowing via R4 also. So then R4 also will detect that fault, no, sir?
R4 is directional, no, it will sense only if the current flows in this direction.
Sir, but at the time of analysis, when we initially assumed it first time, we didn't know it was directional or non-directional. So at that time,
That's what we will, practically we will set it as a directional relay. Here I am going for timing sequence.
So what we have to do is after analysis only we have to do this time thing.
Yes, no, first he has given the question. You don't know which is directional, which is non-directional. Then we have find out which is directional, which is non-directional. Then what you have done? You have gone for the timing sequence.
Sir, during that time only, during the finding out which is directional and non-directional, when fault F1 occurs, R1 current will flow from this left to right, R2 will be from right to left. R3's current will from R3 it will go towards this second bus bar and then come back to F1.
Okay.
So during this
one
traveling,
is in this direction, sir, and the other is in this direction. So what?
So sir, so this R4 is also in the path along the path of R3's current, no, sir. So it should also detect
along the path, but this R4 will not sense because it is a directional relay, no. If you are using non-directional relay, it will sense.
Okay, sir. Okay,
if
sir.
you are using R4 as non-directional relay, it will sense.
Okay, sir. And sir, one more thing regarding this impedance relay, sir.
Okay.
In that impedance relay, we split the Z as R square plus X square.
Okay.
So this R and X are the values of that coil, sir. The coils you are using for V and I.
Not coil, that is the resistance and reactance of that line.
Oh, R and X are the reactance of the line.
That resistance and reactance observed by that line, no?
Oh.
Line impedance, no? Z is line impedance here. Here
okay,
observe,
sir.
This impedance relay is measuring what? Line impedance, line values.
Okay. So from the point of relay to the
line values, line impedance.
From the point of the relay to the end, that is that line impedance.
Fault location.
Okay. All right. Thank you, sir.
That is a Z set, and relay observes whenever the fault that is be up to that fault.
Okay. So no need to include this capacitance effect, sir.
Because when short circuited, the capacitance will not have any importance.
Oh, all right. Thank you, sir.
Venkana Jillapalli.
Hello, sir. Hello.
Ask your doubt.
Sir, in classroom
Ask your
practice
doubt.
question. Sir, in classroom practice question number 2, sir.
What is your doubt?
Hello.
What is your doubt, sir?
Sir, what is the negative sequence current, sir? I didn't get it.
This negative sequence current, about positive sequence and negative sequence we will be studying in faults. Moreover, I will explain here. Positive sequence currents means, suppose if you take IR, IY, IB, okay? These are equal in magnitude and phase displaced by how much? 120 degrees.
120
okay?
degrees.
And here the phase sequence is what? RYB. The phase sequence of this system is what? RYB, measured in clockwise direction. RYB is the phase sequence. Then these are known as positive sequence currents, R1, IR1, IY1 and IB1, okay? And if you are coming to the negative sequence currents, they are also equal in magnitude, IR2, IY2 and IB2. They are also equal in magnitude and phase displaced by how much? 120 degrees. But the phase sequence is reversed. Here RBY is the phase sequence. Then they are known as negative sequence currents. These are positive sequence currents and these are what? Negative sequence currents. We will be studying about the symmetrical components later in fault studies. We will be studying about this.
Sir, okay, sir. When we take positive sequence current in that question, so what will be the answer, sir?
Even if it is positive sequence current also, the answer will be same, because here in case of line to line fault, positive sequence current and negative sequence current will be same.
Okay, sir. Thank you,
That
sir.
depends on fault, sir. We will be studying. Don't worry about this. This is a fault application of faults question in protection system. Okay.
Okay.
Understood my point? We will be
Yes,
studying
sir.
about these faults in fault studies.
Okay, sir. Thank you, sir.
Preetam.
Slide number 34.
Page number
34.
34. What is your doubt?
Sir, here you said that when the voltage is 0, there exists a current, sir.
When even the voltage is 0, if the current is existing, the relay will operate. That's what I have said.
Sir, but if you look at the equation,
Why? Because observe here. Here, if you observe, here operating force is due to what? Current. Restraining force is due to voltage. If the voltage is 0, there will not be any restraining force. But if the current is existing, operating force exists, and this balance will be disturbed, and the relay will operate.
Okay, sir. But the graph and the equation matches, sir. That I is equals to V root of K1, K2.
Okay.
Sir, that is equation for the straight line which is passing through the origin, no, sir?
Yes.
I is equals to V root K1, K2, sir. K2 by K1,
Yes,
sir.
yes. Okay.
That is
what is your problem?
Then the sir.
Why I have shown like this? Here, why I have not shown through the origin? You are asking. Minimum current is required for energizing that coil now.
Okay, sir.
Okay.
Okay, sir. Thank you.
Right. Sunil. Andakumaran.
Hello, sir.
Hello, sir. Ask your doubt.
Hello, sir.
Ask your doubt, sir.
Sir, can you explain the problem, the 90-degree connection, sir? Once again.
90-degree connection problem. Okay. So this one only, no? So here if you observe,
Yes, sir.
in the question he has given 90 degrees connection. In the question he has given 90 degrees connection. 90 degrees connection means instead of VR you are sensing what? VYB. Okay? Instead of VR you are sensing VYB. Now he is saying the fault current lags the system voltage by 90 degrees. This is the system voltage. Fault current lags the voltage by 90 degrees. So CT current lags the voltage by 90 degrees. So flux phi SC will be in phase with this VYB. And he has given the impedance of the PT coil as 0.1 plus j 0.1 ohms. So theta V is 45 degrees. So IV is the PT coil current. So phi V will be in phase with that. Theta V is 45 degrees. Force and torque are directly proportional. So we can write force is directly proportional to K1 phi V phi SC sine of angle between those two fluxes. So F naught is F max sine of that. The force and torque directly proportional. So TOP can be written as T max into sine of angle between those two fluxes. So we know maximum torque given as 10 Newton meter. Angle between these two fluxes is 45 degrees.
Okay, sir. Thank you, sir.
Hello, sir.
Is it clear?
Okay, sir.
Okay.
Hello, sir.
Ask your doubt.
Sir, next problem, sir. Negative sequence relay.
What is your doubt?
Sir, plug setting is a relay pickup value, sir.
Relay pickup value.
Next one, how are you calculating the primary current, sir? I'm unable to understand.
CT ratio. You know secondary side current. This is 0.2. On primary side, you need to calculate, multiply with CT ratio.
Okay, sir. Sir, next doubt is regarding a triple line to ground fault. It is a grounded fault, sir, because the neutral current
is a grounded fault.
But the neutral current is doesn't exist, no, sir.
Neutral current will not exist because why it is not existing? Because it is a balanced fault. It is a balanced fault. Balanced fault means all the currents are equal and phase displaced by 120 degrees. When all the currents are equal and phase displaced by 120 degrees, if you add all those currents, it will be zero.
Okay, sir. But in the introduction, you told that neutral current exists only. It is a grounded fault, sir.
Only grounded fault. Line to ground, double line to ground. Because this is a balanced fault. No, it will not exist.
Okay, sir. So next one, how to identify operating region and non-operating region in graphs? Sir?
Where in case of impedance relay, na?
In any graph, sir. Previous also taught overcurrent and.
Observe here. Observe. Observe here. What is the characteristic you got? This is nothing but a circle equation, no?
Okay, sir.
So you got this is at boundary condition. You have evaluated this. But initially, what I have considered, for relay operation, F naught should be greater than Fr. So here the impedance observed by the relay should be less than this set value under root of K1 by K2. Okay. So here the radius is what K1 by K2. When the impedance observed by the relay is less than that, the relay is operating. So if the impedance falls within this inner circle, then the relay will operate. If it is outside the circle, the relay will not operate.
Okay, so this is Rx plane, but in VI plane, how we are identifying, sir? VI graph.
In VI plane, how you are operating means that the operating quantity is current, no? If the current exceeds that prescribed value, then only the relay will operate.
Okay, sir. So last doubt is, how is the impedance relay is directional, non-directional relay, sir?
Because it is sensing both forward faults as well as reverse faults. Forward fault it is observing, reverse fault also it is observing.
But if there is another relay in first part, will that affect the impedance relay operation, sir?
I'm not getting. What you are saying?
In the red line, in the short circuit form.
This red line is protected by another relay placed at this location, and another relay will be placed at this location. But here, this relay is also sensing that.
But which will be dominant, sir?
Actually, this relay are to be protected only for this black line, but it is unwantedly sensing the fault in other section and disconnecting this. That is not desired. That's why what we'll use, we'll coordinate this impedance relay with a directional element. So whenever you are coordinating with a directional element, it will sense only in one direction.
Okay, sir. Okay, sir. Got clear, sir. Yes, sir. Thank you, sir.
Okay. G. Vaishnavi.
Sir, in 39F, sir.
In 39F. What is that?
Sir, in this circle, you said operating region is above that black line, no, sir. Why can't we say that the operating...
This line indicates the directional element characteristic.
Sir, but the impedance relay is non-directional, no, sir.
It is non-directional, sir. I am using one more element, no, in series with it. Here I am coordinating with another element. Okay.
Below that black line, it can't be operating region, sir.
It will not operate. It will not operate. Whenever you are connecting the directional element with impedance relay, it will behave as directional relay.
What, sir? Can you tell again, sir?
Whenever you are coordinating here directional element, this directional element is coordinated with this impedance relay. This directional element will close the switch only in that particular direction. Okay.
Okay, sir. Sir, again one more doubt. What is the difference between neutral and earth, sir? Hello, sir.
Neutral is the point of interconnection of 3 points in a star point. Okay.
Okay, sir.
Ground is nothing but earth. Earth is nothing but that is zero potential.
Ground means, sir?
Grounding. The ground is nothing but earth potential, zero.
Okay, sir. Sir, can you explain zone potential scheme again, sir?
Zonal protection I have not discussed. No, it will take tomorrow's class. We will discuss that.
Earthing and grounding both are equal, sir.
I'm not getting what you're saying.
Sir, earthing and grounding means both have same meaning, sir.
Here, ground or earth, both are same.
Okay, sir. Okay, sir.
Rakesh Kumar, CH.
Hello, good evening, sir.
Good evening.
Sir, like one basic question, sir. Like fault current direction will be always from the source. Is that correct, sir?
It is right.
Okay, sir. Sir, in induction
Because
cup.
the current is flowing from source only, no?
Yeah, that's fine, sir. And induction cup relay, sir. Like if we change the PT and CT, the whole mechanism will remain same or any alternations takes place, sir?
What you are saying? If you
in induction cup relay, sir, PT and CT, like if we are interchanging, in case of PT, if we are keeping CT, in case of CT, if you are putting PT.
That will produce only unidirectional force. It will not produce any bidirectional force there.
Okay, fine. Sir.
It is not producing any pulsating torque.
Pulsating,
only
unidirectional torque. Okay. And next, sir, and in water relay, sir, we discussed like phasor diagram low I leads V, sir, according to 90 degrees connection.
That is
right,
90
sir?
degrees connection. That
Yeah,
is 90
yes,
degrees.
sir. If we compare with 30 degrees connection, can I say I will be in phase with I? Can I say, sir?
30 degrees connection, I will be
in phase with V. Like V by or something will get, no, sir, in 30 degrees.
So that depends on the load power factor also.
Load, I will be in phase with VRB. Can I say, sir? Load power factor.
That depends. That's what I am saying. In load power factor, that depends on what is the load power factor there.
Okay, sir. And one more thing, sir. Sir, you are telling like reliable protection, no, sir. For every case, we are telling this is a reliable. Like if you consider R1, R2, R3, like just a case, R1 is first, R2 is first, and R3 is first. Some cases we got R3 as reliable protection. What does it exactly mean, sir? Like it won't sense as R1 and R2 won't sense, and R3 will sense.
Reliable means reliable. Remember. Listen here. Reliable means, suppose if the fault takes place in this section F1, okay, this fault has to be cleared by which relays?
Fault R1.
Are you there?
Yes, sir, I'm there. R1
and R2. Because
R1
the
and
fault
R2.
current will be from both the sides. Okay?
Yes, sir.
R1 and R2. But here R4 is also sensing. R4 operation for this fault is not reliable, because if R4 operates, the entire section will lose the supply. No,
Yes, sir.
that is unreliable.
Okay.
It is not desired. Okay.
Okay, particular bus section lo eveveytunto that is reliable for that particular fault antena, sir?
That reliable means that is useful for
Operation of fault. Okay. And one more thing,
Okay,
sir.
for
Yes, sir.
clearing that fault.
Okay. Sir, in like time grading lo, we are discussing like time increases, no, sir. First danki 8, second danki 6, and first. That is at particular instant. Like first oka fault occur avutunanka inko fault
No.
occur.
That we will set that timing. We will give the input to that relay. That is our set value there.
Okay. And in the same way, current grading, sir, we are putting time constant and pickup value.
Time constant and current. Yes.
Pickup value, like that is also we are set value, sir. Like we are putting some
Pickup current and timing set. Timing is also setting, and pickup current is also setting. For a relay, you should give two inputs. One is current as well as time.
Okay, sir. And one more thing, like in star and delta connector, in usual life we have these both connected loads, no, sir. Can I say in star connected we grounded fault occurs, like ground faulted and చెప్పచ్చా? Hello.
Star connection.
Star connected loads లో గ్రౌండెడ్ ఫాల్ట్ అక్కర్ అవుతుందని చెప్పచ్చా?
That is not fault is not depending on type of connection. The fault is outside that connection. No, you can't say whether it is a grounded fault or ungrounded fault. Suppose if you take a delta connection like this, you can't say there will be a grounded fault here also. If the grounded fault can exist like this, this is also a grounded fault.
Okay,
this is also a grounded fault.
Okay, faults exist between phases, not depend on
Fault exists between
phases, like LL, LG, that one. Correct.
This is separate. This is the load side. Okay, suppose. And here the fault may take place between ground, or all types of faults may take place. There is no rule that there will be only grounded faults.
Okay, sir. Sir, and set value just now we derived root k1 by k2, no, sir. Other than that, what is a physical, like exact meaning of set value of a relay? What does that mean?
Exact meaning means that the set impedance you need to calculate, and you should give the inputs, no?
Yes, sir.
That is a physical meaning of that.
Sir, and one more last thing, sir. In 9F, sir, 9F parallel buses ఉన్నాయి కదా సార్, అది సార్ ఇప్పుడు నేను ఫాల్ట్ అనే F2 ఉంది కదా సార్, F2 అనేది నేను R4 రిలే తర్వాత ఇచ్చినాను అనుకో, R4 డైరెక్షన్
రిలే ఇది ఏంటంటే ఈ రిలేస్ అనే సబ్ స్టేషన్ లో ఉంటాయి, లైన్ మీద ఏమి ఉండవు.
ఓకే సరే, R4 డైరెక్షన్ అనేది ఒకటి కన్ఫ్యూజింగ్ ఉంది సార్. లైక్ ఇంతకుముందు మనం ఆ ఎగ్జాంపుల్లోనేమో టువర్డ్స్ లోడ్ ఉంటుంది కాబట్టి లోడ్ సైడ్ తీసుకున్నాం కదా, ఇక్కడ ఎందుకు ఇలా తీసుకుంటున్నాం అనేది నాకు అర్థం అవ్వట్లేదు.
ఎక్కడ ఏ ఎగ్జాంపుల్లో?
అది స్టార్టింగ్ ఒక సమ్ 2 సోర్స్ ఇచ్చారు, మళ్ళీ 3 సోర్సెస్, తర్వాత ఇది సార్ ఇదే
ఇక్కడ ఏం తీసుకున్నా
లోడ్ R5
ఇక్కడ
డైరెక్షన్
సోర్స్ ఉంది కదా, సోర్స్ ఉంది కాబట్టి కరెంట్ ఇట్లా వెళ్తుంది అని తీసుకున్నాం.
ఇక్కడ F3 ఫాల్ట్ ఉంది కదా సార్, అది ఒక్కసారి చెప్పండి. R5 రిలేట్
F3
ఉంటుంది.
ఫాల్ట్ కి ఈ సోర్స్ ఇట్లా డెలివరీ చేస్తుంది, ఈ సోర్స్ ఇట్లా డెలివరీ చేస్తుంది.
ఓకే ఓకే సార్,
అర్థమైందా?
అర్థమైంది సార్. థ్యాంక్ యూ సార్.
రామేశ్వరి.
Sir, I have one more doubt, sir. Sir, ఇందాక చెప్పారు కదా సార్, ఎర్త్ కి పొటెన్షియల్ ఈక్వల్స్ టు 0 అని. సో ఈజ్ న్యూట్రల్ హ్యావ్ పొటెన్షియల్, సార్?
During normal condition, neutral potential and ground potential is same.
Okay.
But if there is any current flowing, suppose if you take the network like this, suppose if you take the star connected system, and if you have grounded the neutral with some reactance of Xn, this is neutral and this is ground potential is 0. Okay, suppose if there is a neutral current flowing through this reactance, then the neutral will be at potential of Vn is equal to In into Xn. Neutral potential will be different and ground potential will be different.
So it's have some potential, na, sir?
Understood?
At that time. Sir, I didn't get it, sir.
If In is 0, Vn is 0, no?
Okay. Okay, sir.
If IN neutral current is not equal to 0, then neutral potential will exist.
Okay, sir.
Okay, right, mute.
Hello, good evening, sir.
Ask your doubt.
Sir, in 39F, how we got the operating region in quadrant, second and fourth, sir?
39F.
Applications of impedance relays unnaya, sir.
This one only, no? This one only.
Yes, sir. The second and fourth
See,
quadrant.
actually here we are coordinating the actual impedance lies circle center at origin, total circle. But
Okay.
here we are coordinating with a directional element. This directional element will operate only in forward direction. Okay. So this directional element characteristic is line like this. Okay. So it will restrict the operation in the third quadrant like this.
Direction okay, sir. At right side direction okay. Direction okay, కానీ second and fourth quadrant లోనే line ఎందుకు వస్తుంది, sir? Hello.
ఇది cos of phi minus tau. Directional element characteristic ఏంది? bi cos of phi minus tau. Is that no?
Yes, sir.
ఓకేనా?
Okay, sir.
చెప్తానా అండి. ఇప్పుడు మనము నిన్న అదొక డయాగ్రామ్ డ్రా చేసాం. ఏంటి?
అవును, సార్.
ఇప్పుడు ఇది 90 degrees కనెక్షన్ తీసుకోండి. ఇది PT వోల్టేజ్, ఇది PT కరెంట్ IV. ఓకే, ఇది ఫ్లక్స్ 5V. ఓకే, మాక్సిమం టార్క్ లైన్ ఎంత ఉంటుంది? ఇది 90 degrees ఉంటే ఇది మాక్సిమం టార్క్ లైన్ అన్నాం. ఓకేనా? ఇది 90 degrees. ఓకే, ఇప్పుడు దీనికి జీరో టార్క్ లైన్ ఎక్కడ ఉంటుంది? ఈ రెండు ఫ్లక్సెస్ జీరో అంటే రెండు కోయిన్సైడ్ అయితే ఇది జీరో టార్క్ ప్రొడ్యూస్ చేస్తాయి. అంతేనా?
yes, sir.
రెండు ఫ్లక్సెస్ కోయిన్సైడ్ అయితే జీరో టార్క్. దిస్ ఇస్ ద జీరో టార్క్. ఓకే, జీరో టార్క్ లైన్. సో ఇన్ దిస్ రీజియన్ ఓన్లీ ద రిలే విల్ ఆపరేట్. అంటే ఈ రిస్ట్రిక్ట్ చేస్తుంది కదా. దిస్ ఇస్ ద ఆపరేటింగ్ రీజియన్. ఓకే,
ఓకే సార్. థ్యాంక్ యూ, సార్. థ్యాంక్ యూ, సార్.
ఓకే, రైట్. అనిల్ కుమార్.
Sir, good evening, sir. Sir, 9F.
Everybody asking about this. What is your doubt?
Sir, from this, the condition, how did you write, sir?
What is your doubt,
TR2 less. TR2 less than TR3. How?
Sir, here observe. Listen carefully. Here, sir, fault F1 is sensed by R1, R2, R3 because one is in this direction and the other is in this direction. Okay, in this direction, R1 is sensing, R1 is operating. No condition for R1. But in this direction, R3 is sensing as well as R2 is sensing. Okay, R3 is sensing and R2 is sensing. So which relay has to be operated first? R2 has to be operated first. So time of operation of R2 should be less than time of operation of R3.
Okay, sir. Thank you, sir.
Goshalya Roy.
Hello, sir.
Ask your doubts.
Sir, in the ring main system, in normal condition, how should we take the direction of the relay, sir?
Ring main system. What is your doubt, sir? What is your direction?
In normal condition, how should we take the direction of the relay, sir?
In normal condition, suppose this is, there are two paths. One is in this direction, the current may complete, and the other one is in this direction.
Okay.
That depends on the impedances of that lines and loads.
Sir, the direction is from source to load like that, or?
Direction will be from source to load only, no issue.
Then R2 direction is R2, R3, the direction is from
Sir,
load.
this R2 should operate for the fault F1, no? Understood my point? For the fault F1, the R2 should operate. Fault F1, one is in this direction and the other is in this direction. Got my point? So that's why I have said that R2 in that direction. And RA for fault F2, one is in this direction and the other is in this direction. That's sorry, and the other is in this direction. That's why I have set the R7 in this direction. Okay.
Sir, in fault F1, what about the direction of R3 and R4, R6, R5?
So one is in this direction and the other is in this direction. No. R3 will not sense that fault.
Okay. Okay, sir.
Abhijit.
Good evening, sir.
Good evening.
Sir, in discrimination for grounded fault, you told that ungrounded fault will not have a neutral current. But when LL fault occurs, there is the system unbalanced, na? So the neutral current will flow as the two fault
That is
get
not the condition.
unbalanced.
Even in case of neutral current will not flow, sir, because that whatever you say at that neutral junction in case of line to line fault, in case of line to line fault, what happens is, suppose if you take the system like this, so this is the neutral point, no? So suppose initially all the currents are 0. Okay. Now whenever there is a line to line fault, suppose, so the current will be circulated in this path. So at this point, suppose this is 10 amperes, this is some 20 amperes leaving. Here it will be 20 amperes entering. So this is the circulating current. At this node, if you apply the KCL, there will not be any. This 20 amperes is entering here and 20 amperes is leaving that junction. No issue.
Okay.
That fault, the line to line fault current will be circulated in this way, in this path.
Sir, but the system get unbalanced, no?
System gets unbalanced. Unbalanced system always it will not result in neutral current.
That's why we are providing neutral to the neutral earth. Neutral is earth in case of a transformer, no distribution.
Sir,
transformer.
here
As system get.
What I am saying is, suppose if you, if my question is, this will be the answer for you. Okay. So here the current is, suppose IR is 0. Initially IY is also 0. IB is also 0. Okay. What will be the neutral current now? Neutral current will be also 0. Okay.
0. Okay.
Now there is an line to line fault occurred. There is a line to line fault occurred. Now IY, suppose instead of 0, IY is how much? Some 10 amperes. Okay. And now IB will be how much? IB is minus 10 amperes because its direction gets reversed, no? So here it is 10 amperes entering, here 10 amperes leaving. What will be a neutral current now? It will be 0.
Okay, okay. Got it, sir.
So
Sir,
we
in
close the
distance
session for today.
Sir, one more doubt.
Ask your doubt.
Sir, in distance relay, you said distance relay is a non-unit type protection scheme. What does it mean? What does
I will
it mean?
explain. It is sensing the faults outside its zone also. Unit selectivity means faults within the zone only. Non-unit means it may sense the faults outside its zone also. Then it is said to be non-unit selectivity.
Okay, sir. Thank you.
Okay, right. Let us close the session for today.
Sir, one doubt, sir.